No, I'd rather Winter had stayed and played more letters with us. It would have been so much more productive.
Well, we got Alan's thing in about 3 minutes. He's gonna do a presentation on relativity. Which, by the way, Alan, are you streaming to your YouTube channel from here as well?
Yeah. Are you a relativist?
I just went live on it. Trying to see
Cool. Do you mind if I play like a minute and a half intro for both?
No, you're good. Are you streaming it too on yours?
Yeah, I'm definitely gonna stream it. But like, I have a minute and a half video on Einstein that I wrote a script for that I put out that I think would work really well as an intro to this. Oh, okay, cool.
Absolutely. Okay.
I might work on the theory of relativity.
Yeah.
It's just like the conclusion is open your eyes, dum dum. The truth is out there.
It doesn't really display full screen, it looks like.
Really?
Didn't you have to do this the last time?
I can't remember, to be honest with you. I'm actually trying it through the application or whatever so that the sound works. See if just making it full screen. Does that work? Does it still look good?
Yeah.
Okay, cool. All right. Yeah, whenever you're ready, I'm ready, man.
All right, hold on. Let me get my intro thing ready then.
All right.
I just started my stream too, and I got a pee, so hold on.
Nonsense that I specifically created to confuse, bewilder, and bedazzle the susceptible sheeple masses into accepting and defending the heliocentric model. The best part is we have now ingrained this nonsense so deep into the current generation that most people actually think I am smart. They don't even know that I married my cousin and then left her for her underage child. Ha 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 ha. The earth is flat globularist. Hello, my name is Albert Einstein.
Love that. All right.
Fantastic.
That's a pretty good preface to get us started. Excellent. All right, man. Take it away. Your show.
That's great. Okay. So it turns out I was able to get it on YouTube. I just had to lower the frame rate a little bit. So we're still good.
Cool.
So this is how math became reality, a comprehensive look at the history and classical experimental evidence that's put forward in support of relativity theory. We didn't have a format or whatever agreed upon, so I'm just gonna kind of set some rules or some structure right now. There's a lot of ground to cover, so I'm gonna go through like a series of slides, and then I'll do like a Q&A on them, see if there's any questions, and then we'll move on. Sorry, I'm a little nervous. Okay, so abstract. Relativity theory has been around for over a century, and now to this day, acolytes in support of the theory have completely surrendered their faculties to equations and concepts that they don't fully understand or care to. The classical proofs of relativity theory are often cited to hand-wave dismiss any criticisms of the theory, despite supporters of the theory not being able to describe exactly what spacetime is. This presentation attempts to make clarifications on what spacetime is, and taking it a step further, I will make the case that spacetime has to be a physical entity if any curvature thereof was to be responsible for the physical effects that are attributed to proof of the theory. The classical proofs of relativity theory are the perihelion precession of Mercury, the deflection of light rays by the sun, gravitational redshift, and miscellaneous indirect confirmations of the theory such as time dilation and the equivalence principle, and some other ones that we'll go over later. If relativity theory were to supersede the Newtonian framework, it would need to prove that the concept of spacetime is a physical entity and has a mechanical cause and effect relationship with how it interacts with physical objects and electromagnetic energy. Here we will examine the historical narrative and experiments that are put forward to support the physicality of spacetime. It is my intention to use this presentation as a vehicle to provide clarification on relativity theory by demystifying and translating the equations and experimental proofs in mechanics used as evidence for the theory. So moving on, we have a quote from Einstein when he first submitted his general relativity theory. He states that if any of these three things were to be proven wrong, that his theory would collapse in on itself and it would shown to be false. And that's the perihelion and the deflection of light rays, i.e. gravitational lensing, and gravitational redshift, which will be getting covered in the as we continue. So the prerequisite.
Hey,
go ahead.
Do you mind if I throw something in real quick? I was just outside. I just wanted to tell you guys about this. And
No, definitely don't, dude. It's a
No,
presentation that we're trying to live stream. Come on,
no,
definitely not the right
What are
time.
you talking about, bro? Like, no.
Oh,
Well, okay, never mind. I'll just leave. Bye.
Yeah, good call. All right. So prerequisite information, a lot of these measurements and what they're talking about that they use for proofs of general relativity is done in arc seconds and arc minutes. So to give an illustration of what that is, if you take a degree, you can break it down into 60 sections, and that would be 1 arc. Each section would be 1 minute of arc, and then you could break each minute of arc into 60 seconds of arc. So you can get down to an accuracy of 1/3600th of a degree. That's like what they're claiming to measure the angles and precision of degrees within 1/3600th. And then due to atmospheric conditions and stuff, you know, when they start talking about stuff produced from like satellite images and quote unquote where there's no atmospheric condition, they claim that they can get into these milliarcs and micro arc seconds, which is even, you know, more precision. But you know, we all obviously all know that's BS. But that's how the system works. So more prerequisites: space-time, metric tensors, geodesics, and transformations. The geometry of space-time is described using a mathematical construct called a metric tensor. How one might use a metric tensor, how one might use the metric tensor framework for practical purposes. And in the example of engineering, you could use the framework to describe a Cartesian coordinate system, the XYZ axis, to define the dimensions of an I-beam, and then you could use that to show how much stress would be exerted at any particular point, you know, on the I-beam using that coordinate system. You can even use it to show a stress relationship between 2 different points within the I-beam. So that's basically what they do when they're talking about, you know, gravitational warping and bending. They've basically came up with an XYZ coordinate system. Well, I'll just keep continuing anyway. Similarly, space-time metric tensors describe the geometry of space-time by adding t as the 4th axis to the XYZ coordinate system, XYZT. In relativity theory, the axis of the coordinate system can be bent, warped, and distorted, or expanded, or even contracted. Objects in motion in relativity theory are described by the XYZ coordinate system, XYZT coordinate system, as traveling on geodesic paths, which they describe as just uniform straight lines. By adding the 4th dimension of time, the coordinate system can be described as giving like a 4th dimensional perspective to it. So it's even though we see things moving like in a curve, that's just from our perspective. What they're saying is that everything's moving in a straight line, and it's just moving through the curvature of space-time, which is actually producing the curve, like the curved orbits and elliptical stuff that we see in the sky. They're saying like that's how they describe it in the mathematics, as straight lines that are just traveling along curvature of space-time. Since the XYZ curvature system is relative, the maximum speed of light in a vacuum is introduced as the constant that can be used to measure the distance of time within the space-time metric. In order for this system to describe reality, the speed of light must be shown to be the same in all reference frames. A quick note on reference frames: a reference frame is a way of describing relative motion between observers. It has been experimentally shown that c has variance to it. However, to mathematically demonstrate the presupposed axiom of c being constant, with which relativity is entirely built upon, equations known as the Lens transformation are used to express how the coordinate system is being stretched and contracted in such a way to explain the results of optical experiments using interferometry, such as Michelson-Morley, Sagnac, and others, which we'll get into later in the presentation. So there's a video here that we're not going to watch because we're going to be pressed for time, but it gives an excellent visualization on how this matrix right here can describe a coordinate system that defines an I-beam and how they do that. So it does have like practical application, but they've just, you know, got real theoretical with it, if you know what I mean. So this is the equation here for the Lorentz transformation. They basically apply this to any results and measurements they get, and that's how they make time and distance and length relative. They show the contraction with this by just transferring the reference frame to whatever relativity would quote unquote predict, and then they go, oh look, it's proof of relativity. Does that make sense so far? Cool. Moving on. Here's some examples of space-time metrics and curvature tensors that they use. These are equations or solutions that are used to affect mass and energy on the space-time coordinate system, which is used to describe a type of distortion that's being experienced to explain the relative celestial phenomenon or hypothesis about it. Commonly used metric tensors. The Schwarzschild metric used to describe space-time outside a spherically symmetrical, non-charged, non-rotating mass, such as a black hole. It describes the curvature of space-time due to the mass of an object and due to the motion of a massless object traveling through the curvature of the big object. The Kerr metric used to describe space-time outside a spherically symmetrical charge rotating. It's basically the inverse of this. It just accounts for charge and mass and rotation and all that, because that affects how much the gravitational field is influenced in space-time. So this is what they would use to describe two black holes rotating and coalescing and all that. And then this is the FRW metric. This is used to describe the large-scale structure of the universe and framework of cosmology. It assumes homogeneity and isotropy in the universe and describes the expansion of the universe as a function of time. This metric is used to calculate the evolution of the universe and the properties of celestial objects such as galaxies and clusters. So what they do is they assume that there's an even distribution of mass and energy so that they could make calculations and quote unquote predictions, just basically line up what their observations are to the blank slate framework that they have. So that's what they're doing with that. And these are curvature tensors. Curvature tensors are used to describe the curvature of space-time, which is related to the distribution of mass and energy in the universe. The Riemann curvature tensor and the Ricci curvature tensor are two commonly used curvature tensors that can be used to determine the equations of motion of objects in a gravitational field and the distribution of energy and momentum in the space-time coordinate system. So by combining these and swapping them out, they can just kind of say whatever they want and describe anything they need to. So if they make assumptions about the universe, they can calculate it. More prerequisites: spectrographs and spectral shifts. A spectrograph is a scientific instrument used to analyze the spectral shift in light emitted by a source such as a star by separating it into its individual colors or wavelengths. This is done by directing the light through a diffraction grating or a prism, which splits the light into its component colors. Refracts the light into different angles based on its wavelength. In the past, photographic plates were commonly used according to the resulting spectrum. By analyzing spectrum shift, you can determine energy and frequency in the wavelength of light, which can provide energy about what happens to light during its journey. For example, light traveling through a gravitational field is expected to lose energy, causing a frequency shift in wavelength, decreasing or shift in wavelength, which decreases, resulting in a spectrum shift known as gravitational redshift. This is different from velocity shift or Doppler shift, which can be demonstrated by an observer whether the light is blue shifted or red shifted, depending on the source of moving towards the observer or away from him. General relativity attempts to distinguish redshift due to velocity shift, which is caused by relative motion, or distinguish from gravitational redshift from velocity shift, which is caused by relative motion. The redshift caused by relativistic conditions such as traveling through a gravitational field such as space-time curvature. In the case of gravitational redshift, light traveling through a gravity field loses energy, which results in decreasing in frequency and wavelength, or an increase in wavelength, resulting in the redshift of light. The spectral shift phenomenon is presupposed. The spectral shift phenomenon, after presupposed corrections are made and the correct transformations are applied, relativistic results can be extrapolated from experiment and then attributed to the theory. So this is what happens. They got a telescope. They're looking at starlight. It goes through, hits a prism, and then the wavelengths hit a photographic plate, and then they compare that to the color spectrum, and they're just extrapolating, the information from that. This video we are going to watch real quick. It's a 3-minute video, I think, and it explains Doppler effect and how waves work and relative motion and all that. So this will give us a nice foundation moving forward, because a lot of relativity hinges on this stuff. Basically all of it.
The Doppler effect. In Sheldon's words,
it's the apparent change in the frequency.
Are you guys getting the audio okay?
I don't hear any audio.
I don't hear anything.
Did you play it yet?
A wave caused by relative motion between the source
of
the wave and the
nope.
observer.
Why is it doing that? That's so gay. All right.
That guy on the left in the video is gay. So
Yeah, he is.
Good call, Jim.
But we'll skip that slide from now and come back to it. We won't. Hold on 1 second.
Plays your hot mic in.
What'd you say, Shane?
I said Blaze is hot micing. We got it.
Change screens.
So in Discord, are you sharing the screen or the application?
Application.
Yeah, should be fine. Can't help you out. I don't know why it's not working. Oh, there you go.
Yeah, how's this?
There you go. That works.
Okay.
The Doppler effect.
Yes.
In Sheldon's words,
it's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
You got to put the volume up a little bit.
Oh, my bad. Sorry.
Yeah, you have YouTube. Well, there you go. Good to go.
Effect is perhaps best explained visually. So here's a thing that is emitting waves. It could be a fire truck emitting sound, it could be a star emitting light, it could be a duck creating ripples on a pond. Those are all waves, and they all look something like this. We see the Doppler effect happening when the thing that is emitting waves moves. In the direction it's moving, the wavefronts bunch up, and behind it they spread out. If our object is moving towards a stationary observer, these bunched up waves are observed at a high frequency, and if the object is moving away from a stationary observer, the waves are observed at a lower frequency. So that is the Doppler effect, the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer. It makes sense, but it gets interesting when you consider some of its applications. So let's say you are standing in the middle of a road. That's you, and a car drives. Higher frequency light waves means bluer light, and lower frequency light waves means redder light. This is called redshift, and it may possibly be among the weirdest and coolest things of all time. Stars, or anything that you can see, change color depending on their relative motion to you, away from us very quickly, which is both an important piece of evidence for the Big Bang and an indication that the Earth might get very lonely in the distant future. Thanks for watching this video. Let me know if you got something out of it. Bye.
All right. So that played all correctly?
Yeah, but you kind of stuttered a bit. Maybe if you switch your sharing quality down a notch because you're at 2K.
Yeah, I did. I just realized that. I just saw.
Oh, you did 1080. Okay, cool.
Yeah. So basically, waves coming at you are at a high frequency, which produces blue shift, and waves moving away from you produce redshift. They decrease in frequency. That's basically what the TLDR on that video was, but it just gave some really nice visuals to it. Highly recommend checking it out. I'll link it later, but we'll continue on. So we're almost done with the prerequisites, and then we can get on to the gravy, I promise.
So we're not refuting any of that, right? We're saying that that's an example of something that's a measurable effect, right? The Doppler shift.
Yeah, the Doppler effect. Yeah, and then how they were tying in, the redshift and stuff. That's just the mainstream explanation of what they're doing, of how they're going about using redshift to prove relativity theory. It's just giving them like the background history on what it is.
Right, but like I've heard car horns sound exactly like that, so that seems to match reality to me. So I'm not going to refute that whole thing, right?
Oh, yeah.
Okay.
This is just going through the how it works.
Gotcha.
So prerequisites: standard observational conditions when using a telescope. Viewed at a high power from the bottom of our ocean of air, a star is a living thing. It jumps, quivers, and ripples tirelessly, or swells into a ball of steady fuzz. Rare is the night at most sites where any telescope, no matter how large its aperture or perfect its optics, can resolve details finer than 1 arc second. More typically, at ordinary locations, is the 2 to 3 arc second seeing or worse. That's from McRoberts, 1995, from a magazine called Sky and Telescope magazine. Just kind of giving you some perspective on these measurements that they say they take. So remember, dude saying that. Sorry, go ahead.
Can you measure the Doppler effect without a stationary position?
Yes. Police do it all the time.
So I guess that's based on relativity math. Is that what you're going to tell me?
No.
Okay, well, tell me how you come up with Doppler effect without using a stationary point of reference.
Yeah, because that, again, it requires specific points.
You just account for your motion. Like, that's how police radar works when they do the thing to...
No. The Doppler effect is based on stationary points of reference. And now I'm curious, man. I want to know. Like, so you're telling me that you can explain this from some kind of mathematical equation?
We have, apparently. But
well, the whole definition of radar is based on a stationary point of reference. Man.
Yes. Let's let him get to the gravy, though.
Okay. Anyway, so we're going to cover the experimental evidence that's put forward now. The perihelion precession of Mercury. Perihelion precession of Mercury and why it's important to relativity theory. The perihelion precession of Mercury is the gradual shift in the position of Mercury's closest approach to the Sun, the perihelion, over time. In 1846, Urbain Le Verrier observed and recorded the perihelion precession of Mercury's orbit around the Sun. He calculated the perihelion precession to be about 5,600 seconds of arc per century. Many years later, Newtonian mechanics and relativity theory faced off to account for the perihelion precession. Here are the results. The claimed actual observed amount, 5,600 arc seconds per century. So if you remember back how the arc seconds work, that would be about 1.5 degrees is what they're claiming to have measured as a projection over 100 years. You know, who knows if any of this is even real and if they even made those kind of measurements, but they've mathematically extrapolated this and that's what they're going with. So Newtonian had to explain this with his mechanics, and he basically added up all the gravitational forces of the other planets and kind of explained it as like a tug of war going on with the Sun. And the closest he could come up with his using his figures was 5,557 seconds of arc, and then relativity predicted 5,600 dead even. So Newtonian mechanics was off by 43 seconds of arc seconds per century, while relativity theory, using a modified Schwarzschild metric, Einstein was able to match match Einstein's observed, match the observed gravity as space-time curvature, and gives the appearance of physical solutions using mathematical concepts. For clarification, no prediction of general relativity. This is not a prediction of general relativity. This is a postdiction. All right, so to give a visualization of what they're saying, say this is the equator of the Sun, and Mercury, would supposedly orbit around this every year without fluctuating at all. They're saying that they measured this slight fluctuation down to fractions of a degree, right? So like down to down to 0.43 seconds of arc. So from the Earth, from 93 million miles away. Other theories and explanations to propose an equation that describes a gravitational waves propagating through a medium which matches the speed of light. So this is the equation that I'm just going to kind of speed through this because we got so much to go through. This is just going to summarize quickly. So this is the equation that he used, and his reference in T right here is describing the time that it takes for the gravitational influence from the Sun to propagate to Mercury, and that causes the precession. His solution was ultimately rejected because his attempt to explain the mechanics of how the gravitational wave would propagate through the supposed medium that he supposes with T, he had no physical mechanism for it, and there was no way to extrapolate a justification for adding T to Newtonian mechanics, so they kind of disregarded it. But this is to show you that using math, you can do it's totally solvable within Newtonian mechanics, but they're going to make this argument that it's only solvable through general relativity. So this is Einstein's equation, and they're eerily similar. They're pretty much the exact same. The only difference is Einstein uses a capital T, and he describes that as the time of Mercury's orbital period that it takes to complete a full orbit around the Sun. And then obviously his mechanism is different than wave propagation through a medium. So while Einstein's theory offers no physical mechanism either, it offers an alternative explanation to the very nature in which light travels by use of the metric tensor from Einstein's field equations, which describe the bending and warping of space-time. The coordinate system, such as a photon, would be traveling through the curvature of space-time, would not be on a true geodesic, and that the optical effect of the perihelion precession.
So, oh wait, can I ask a question about that slide? Yeah, the one right before.
Oh yeah, sorry, go ahead.
That picture in the lower right, is that not the Tycho Brahe geocentrist take on the motion of the planets? Why are they using it, or are you just putting it in there?
No, I just put it in there for graphic effects. So some of these are unrelated to what it is, because I just wanted something cool to look at, and like this picture is awesome. So
definitely describes what he's talking about way better than Einstein did. Anyway.
Yeah, shout out to your boy Tycho Brahe.
Right.
he gets it. So Paul Gerber continued, it should be especially noted that Gerber's equations were mathematically sound. The criticisms of his explanation come from the fact that he didn't have a physical mechanism for the propagation of gravitational waves through his supposed medium, or a principled theory as to how the corrections were to be derived from Newton's framework of interpretation. On these grounds alone, even though the math worked out, his solutions were rejected. So this guy isn't allowed to swap out tensors and invent new things, but the Einsteinian framework has it built in where all these things are interchangeable as long as they agree to play within the space-time framework that they can go with, and that's why they can describe all these crazy things using different equations and transformations and stuff. It has no physical meaning to it, but they act like it does through claiming experimental evidence and stuff, which we're going to go over and show that none of that's true, and they don't have a physical mechanism for anything. So with protections like that, Einstein's theory of relativity can't lose. So this is what the Schwarzschild metric looks like. It starts out describing the geometry of space-time, and then this is the part where they get their mathematical corrections or predictions for redshift, and then this goes on to describe the rest of the coordinate system and angles between. So what they do is they'll describe like the mass of a star and its size and stuff, and then they'll extrapolate the angles between the zenith of the star and the center of mass of the the presupposed center of the mass of it or whatever. So what does all this mean? Basically, the Schwarzschild metric is an equation that assumes the ideal conditions for calculating gravitational effects on massless objects whose rotation charge potential and overall shape are all disregarded, as they would change the results of the curvature of space-time. In short, the Schwarzschild metric is a fancy way of saying there's no solution for the three-body problem. It's just a way to impose the ideal conditions on optical phenomenon, and to calculate and to say that it's attributed to a gravitational field and all these hypothetical effects. So math is a language, and with any language you can tell a story. The Schwarzschild metric is a story, and the radial coordinate is a way of describing the position of an object in the terms of space-time. Yeah, okay. All right. The conclusion to the Mercury perihelion precession. Theories and solutions derived from the principles often do not match observed reality, and the math used by Einstein has been criticized as being manipulated to produce the desired results to fit the experimental outcome.
There you go. There you go. Now you're getting up there. Now you're getting.
All right, please stop doing that. Other competing theories that exhibit the same issue are dismissed. While Einstein's solutions are not held to the same standard, modern physics and cosmology allow for the changes to be justified by simply stating that space-time behaves differently under certain conditions and expressing that assertion mathematically. However, space-time is not a physical object that can be measured, so we cannot trust the mathematical description and the presupposed behavior under certain conditions imposed, or under the imposed conditions, even if the theory cannot be physically confirmed. The other possible explanations for the whatever it's called, the perihelion precession of Mercury, a perturbation caused by other planets, which that's what Newton tried to say, but you can still adjust the math to make that work. They just act like they can't. Gravitational effects of the sun's oblateness. So this is something that that they're kind of talking about now. because the Schwarzschild metric describes the sun as a perfect symmetrical sphere, but in reality or whatever, they say the sun is oblate, similar to how they say the Earth's oblate. It's flat at the poles and wider at the equator. So they're saying that the oblateness gives gravitational anomalies that account for the precession, the alleged precession of 1.5 degrees over a century. And they also were trying to say, yeah, this is a funny story. So they also they theorized that there was another undetected planet called Planet Vulcan, and they were actually ready to roll out the whole Vulcan story. And they sent a guy from the Royal Society to interview a guy that supposedly seen this planet Vulcan that confirmed the gravitational interference of Mercury. And they were all ready to roll it out and published, works on it and announced it. And people were saying, "Oh yeah, dude, I saw a Vulcan too. I saw it last night." I linked a video to a guy named Vat City on YouTube who does an excellent presentation on this. It's a really interesting and funny story because, they were just going to go with anything to kind of explain this and maintain their grip on everything. And they just kind of shoved this under the rug and act like Einstein. I think if you Google Einstein the planet killer or whatever, like the story will come up and make it seem like Einstein's a hero and that he destroyed a planet. It's pretty funny. And the ether drag, which we're not going to get into. All right. So the deflection of light rays. So to recap real quick, general relativity didn't prove anything here so far, right? They've just kind of mathematically finessed the theory to fit these supposed observations while suppressing any narrative that any other theory can explain it using, math. And they act like Einstein, just saved them from this terrible perihelion precession problem that they were having. So continuing on, the next proof of general relativity was the deflection of light rays, aka gravitational lensing. Gravitational lensing. Was there any questions or anything for anything like how that worked? Is everyone good?
They mathemagic themselves from preconditions to an outcome. So they made no predictions, right? They've just observed what will happen.
They've really patted themselves on the back in the way that they control the narrative and tell the story. Like when Professor Parks was on here, for example, good guy and everything, but he was literally like, they just start off by going, the perihelion precession was predicted by, like, they just go through this whole thing, and it's not true at all,
Parks is chilling with us. CC's here right now in case that changes your
no, it doesn't. I'm glad he's here.
Okay, cool.
Because they all do it. That guy Blitz was doing it during the debate with Austin 2 weeks ago. They just start firing it off as if it's like this cold hard fact that can't be disputed. And even within the own paradigm, the official narrative stuff doesn't work on it. It's not true at all. Well, we'll talk about it towards the end, Rob. But you were starting to go into it, and I started talking to you about this.
Nice.
But yeah. So the deflection of light rays by gravitational lensing. Newtonian physics and Einstein's relativity theory make different predictions for the deflection of light rays. Einstein's relativity theory. Yeah, my bad. I don't mean to misrepresent you, because I did cut you off in the middle of when you were talking, but you were literally saying you were going through the script of Eddington, proving relativity theory and these predictions. So, but if that, anyway, we'll continue on later. Sorry about that. And I don't mean to misrepresent you. Newtonian physics and Einstein's relativity theory make different predictions for the deflection of light rays. Einstein's theory of general relativity predicted that light would be deflected by a gravitational field due to the curvature of space-time caused by mass and energy. Newtonian physics predicted that light would bend by half as much predicted by relativity theory and by a different mechanism. In Newtonian mechanics, gravity is considered a force, which in the traditional sense is described as a mechanical attraction between masses, mass attracting mass. Newton thought gravity would act on the light as if it was a particle. In Einstein's relativity theory, gravity is not considered a force in the traditional sense, and it is rather the curvature of space-time caused by mass and energy. Differential equations called metric tensors used in general relativity provide geometric interpretations of gravity in which the presence of matter and/or energy cause the curvature of space-time that dictates the motion of a gravitational field. Einstein's concept of curvature in space-time usurped Newtonian mechanics or Newton's mechanical attraction force as the dominant explanation of gravity for for celestial phenomenon. It should be noted that no one has ever seen gravitational lensing or an Einstein ring with their own eyes. It is the only evidence for gravitational lensing is imagery that comes from computer processed imaging, such as the James Webb Telescope and the Hubble Telescope, etc. So moving on to the observational evidence that's put forward. This is Arthur Eddington and his expedition to prove relativity theory by way of gravitational lensing. On May 29, 1919, British astronomer Arthur Eddington led an expedition to the island of Principe off the west coast of Africa during the total solar eclipse. The purpose of the expedition was to determine the accuracy of 3 theories regarding gravitational influence on starlight causing the displacement of the predicted amount. The theories were no gravitational influence, or no influence from gravity, an effect in accordance with Newtonian law of 87 seconds of arc, or 0.87 seconds of arc, or one that agreed with general relativity, which predicted 1.75 seconds of arc. The expedition aimed to distinguish between these possibilities. The data he had collected on that day would be used just 7 months later to solidify the direction of physics and cosmology for the next 100 years. Arthur Eddington's data. Unfavorable weather conditions rendered almost all of his photographs worthless. As time went on from his initial discovery, Eddington's story changes to bolster his conviction and the evidence or lack thereof. Eddington wrote Fowler in 1919 before returning from his expedition. June 3, 1919. The cloudy weather upset my plans, and I had to treat the measurements in a different way from what I had intended. Consequently, I have not been able to make any preliminary announcements of the results, but one plate I measured gave a result agreeing with Einstein. June 1919. I secured 16 photographs, but only was the last 6 was the sky clear enough to show any stars on them. I only got between 3 and 5 images, and as the sky was generally only clear on one part of the plate at a time, the stars secured on the plates were badly distributed. However, one plate has some evidence of deflection in the Einsteinian sense, but the plate errors have yet to be fully determined. The results are and then later on in his life, he states, the results of the plate gave a definite displacement in good accordance with the Einstein theory and disagreeing with Newtonian's predictions. Although the material was very meager compared to what we had hoped for, the writer, who must be admitted was not altogether unbiased, believing it to be convincing. And then later on in his memoirs, or was autobiography or whatever, or regular biography. In later years, Eddington referred to his findings on May 1919 as the greatest moment of his life. So he just kind of flip-flopped as time went on, and basically, to give a quick rundown, him and his boy Cromlin set out on 2 different spots. Eddington went to Africa, Cromlin went to somewhere in Brazil, and all of Cromlin's data was dismissed due to quote-unquote temperature errors. But basically, it's kind of stated that all his observations gave, in accordance with Newtonian predictions. So all of those were discarded, and then the only two plates out of the 16 that Eddington took are used as evidence to support the gravitational, the displacement of starlight by the gravitational influence of the sun. So Eddington data continued throughout different stages of his life. I just kind of covered that. So he went as far as to backtrack the story about the poor distribution, later claiming in a paper published by Dysons and others in 1920 that the 5 stars shown on the 2 plates from principle include almost all the essential stars, and even further suggest that the cloudiness may have been beneficial from preventing overexposure from the brightest stars. So this is 7 months later. They had a meeting. The Royal Astronomical Society and the Royal Society got together, and this is where they were going to give an announcement on the results of Eddington's observations of his 2 photographic plates and give a positive confirmation of relativity theory. The controversy and accuracy and merit of the data collected is a common, mainstream point of contention in the story. However, there is a more subtle conversation being had over an entirely different aspect of the data that proves devastating to the narrative that the 1919 eclipses support relativity theory. Using the observatory volume 42 in these pages, we're going to go over the transcripts of this meeting and see how they talked about the data and how they moved forward with accepting this as proof of relativity theory. So, Sir Joseph Thomson, President of the Royal Society. It is difficult for the audience to fully weigh the meaning of the figures that have been put before us, but the Astronomer Royal and Professor Eddington have studied the material carefully, and they regard the evidence as decisively in favor of the larger value for the displacement. He further says, if the theory is right, it makes us take an entirely new view of gravitation. If it is sustained that Einstein's reasoning holds good and it has survived 2 severe tests, then this is the result of the highest achievement of human thought. The weak point in the theory is the great difficulty in expressing it. It would seem that no one can understand the new law of gravitation without a thorough knowledge of the theory of invariance and without knowledge of the calculus of variation. One other point of interest arises from this discussion: light deflected and passing near large bodies of matter. This involves alterations in the electric and magnetic field. This again implies the existence of an electric and magnetic force outside of matter, forces at present unknown, although some idea of their nature may be got from the results of this expedition. So right off the bat, the president's given a positive confirmation of the data, hasn't even talked about, how there was 36 slides taken, only 2. There was a bunch of problems with it. They actually didn't even, the reference slides they couldn't even use. They had to use a different set that were taken like a year prior, using different materials too. So they had to, make corrections and adjustments to even account for that stuff. And it just so happened to work out in favor of relativity according to their math magics, as Shane stated. And this is Arthur Eddington at the meeting. We know that the momentum is carried along the path of a beam of light. Gravity in acting creates momentum in a different direction of the path of light as to cause it to bend. For the half effect, we assume gravity obeys the laws of Newton. For the full effect, which has been obtained, we must assume that gravity obeys the new laws of Einstein. This is the most important and crucial test between Newton's theory and the newly proposed laws of Einstein's laws already indicate a perturbation causing the orbit of Mercury to resolve. That confirms it for the relatively small velocities. Going to the limit where the speed is that of light, the perturbation is increased in such a way as to double the curvature of the expected path, and that has now been confirmed. This theory may be taken as proven Einstein's law rather than his theory. It is not affected by the failure to detect displacement of the Fraunhofer lines in the sun. If the latter failure is confirmed, it will have no effect on Einstein's law of gravitation, but it will affect the views on how gravitation was arrived at, or on how the laws were arrived at. The law is right, though the fundamental ideas underlying it may yet be questioned. One further point must be touched upon. Are we to attribute the displacement of the gravity? Are we to attribute the displacement to the gravity field of the sun and not to refracting matter around the sun? The refractive index required to produce the results at a distance of 15 arc minutes from the sun would be that given by the gaseous pressure of 1/60 to 1/200 of an atmosphere. This is too great of a density considering the depth of light. So what he's saying here is basically his data only shows displacement around the solar limb of the sun. So right here where there's an expected, plasma medium and all that. And they're trying to narrow it down and say, like, is it due to a refractive medium or is it due to space-time curvature? How do we distinguish? Because the other stars that were, around this area of the sun that should have been displaced due to the sun's gravitational field, there was no displacement, which we're going to go over here shortly. But that's kind of what they're alluding to. And then the Fraunhofer line stuff, there was supposed to be gravitational redshift and spectral data readings done during this observation, actually in tandem with the observation, to establish a cause and effect relationship with the bending of with the displacement of starlight. But they and without that, there can't be, they can't say that any displacement is due to space-time curvature or gravitational fields, right? That's kind of how that works. So continuing on with the transcripts, this is Frank Watson Dyson. To the right, 2 photographs of the eclipse expedition are put forward as evidence, and this is just what they're talking about. On the day of the eclipse opened cloudy but later cleared, the observations were carried out with almost complete success. So the guy who wasn't even there, who even got explicit detail saying that the the conditions were dog shit and the evidence is poor, it opened clear and it was a complete success. The plates were measured at Greenwich immediately after the observers returned. Each plate was measured twice over by Monsieur Davidson and Ferner, and I am satisfied that if such faults lie, that if there are faults in the results, that they lie in the plates themselves and not the measurements. So after a careful study of the plates, I am prepared to say that there can be no doubt that they confirm Einstein's prediction. A very definite result has been obtained, that the deflection of light rays is in accordance with Einstein's law of gravitation. So these guys are all falling into line here over these two plates. Alfred Fowler, president of the Royal Astronomical Society. The quantity looked for, I may say, is 100 times the probable error of the measurement which can be made with the large spectrographs now employed in such inquiries. Evershade has also examined the light from the side of the sun away from the Earth by photographing the spectrum of Venus when on the further side of the sun. Gravitational displacement, if any exists, should appear in all parts alike, but he finds no such displacement on the other side of the sun, though he does get a slight displacement on the near side. It is very desirable that the spectroscopic test should be carefully repeated. So this guy's kind of bringing up that they have the technology to make these detections to prove a cause and effect relationship with the displacement, but there isn't any. So he's kind of concerned about that. And then Professor Lindemann adds in, as to the theory itself, I must confess the fact that it is always presented in the purely mathematical point of view seems regrettable to a mere physicist. No doubt that the present form is correct, and even elegant once has become familiar with the notion. I cannot believe, however, that a profound physical truth cannot be clothed in simpler language. To put the theory in the form of curvature of space-time manifolds seem to be much simpler than the tensor presentation. Cannot Professor Eddington translate his admirable treatise from the tensor notion into some such form? So basically, he's saying we're never going to convince the people or explain this theory if we just talk about like the mathematical mechanics of it. We should go with the metaphorical space-time manifold curvature and use that to explain it. He's a big fan of that. He likes it. And this is Professor Hugh Frank Newell. May I add my congratulations to the extraordinary success of the observations. I feel that the Einstein effect holds the day, but I do not yet feel I can give up my freedom of mind in favor for another interpretation of the effects obtained. If Einstein had not existed or had not predicted the deflection, we might have had a similar experiment made to test the presence of an extended atmosphere around the sun, and we could have argued the results back to the hypothesis. Think for one fine moment of the prominence that was seen on the day of the eclipse. It was followed by Evershade for a rotation and a half, and that's the guy who did the spectroscopic, the Evershade guy. Matter was expelled outwards from the course of the movement, as we know from the sequence of photographs secured by the spectroheliograph at Cambridge on the day of the eclipse, and yet matter at different high levels goes around the sun, not with gravitational velocities, but with the same velocities that hold at the lower levels of the spots. It is, I know, a cheap criticism to make a qualitative suggestion in opposition to a quantitative result, but I feel that I want to keep an open mind for the existence of a field where gravitational and electric forces are acting simultaneously in an unknown relation under conditions which admit the existence of an extended corona. It does not carry much weight to me that it is urged that to explain the deflection in terms of a refractive index that the medium having a density of 1/200 or 1/40 of that of a terrestrial atmosphere would be needed, for we have to do with a possible extended solar atmosphere at very high effective temperatures, almost certainly in part controlled by electric as well as gravitational conditions existing in it. And who's to say what its refractive properties may be? I prefer to keep an open mind about the interpretation, but I wish, in conclusion, to add my heartiest congratulations to the Astronomer Royal, in the observations on the observers and the observational results obtained. So this guy's giving some pushback on the refractive index stuff, and he's still down for saying that, there's something that could be going down with the solar limb, but they really have to get away from that if they're going to use this as solid evidence for relativity theory. So Professor Frederick Lindman chimes in. Might I say one more word? Have we not evidence for motion of comets passing near the sun outside of the sun? Might I say one word? Have we not evidence from the motion of comets passing near the sun that the matter outside of the sun is distinctly diffuse? Comets suffer no noticeable checks in their path. So this guy's saying that when comets go by the sun, the tails don't get, split up or shifted or anything. So there's probably not any extended medium around the sun. And then this is Dr. Silverstein, who I call Whittitt's great-grandfather. But in spite of what the president said, I believe this result to be essentially an isolated fact. There is a deflection of light rays, but it does not prove Einstein's theory. It cannot logically be deduced from his theory of gravitational effect in absence of the spectroscopic results. And as far as we know from St. John's and Evershade's observations, the predicted shift in the spectrum lines of an amount exceeding almost 100 times the probable error of the modern spectroscope, as Fowler had just told us, is not obtained. Professor Lindman's attempt to explain the obstinate nullity of this effect by motion in the luminous gases in the line of vision is not satisfactory. For St. John's was well aware of such complicating circumstances, and therefore purposely observed as many as 43 lines at the sun's center and almost as many as 35 at the limb. Now we cannot assume that gases move everywhere and towards or away from us, only to suit Einstein's theory, i.e. just to compensate for his theoretical shift. As I have pointed out on another occasion, if there is no spectral shift, Einstein's coefficient, which is how they describe space-time curvature in their metrics, which is entirely responsible for it, must become unity. And if we go back to the differential equations, Einstein's field equations, we shall see at once that the coefficient and his well-known approximate solution becomes unity at the same time. And then he starts talking about the equations that are used, and so that the word element simply reduces to, and then this is where he's talking about the geometry of space-time and the curvature of space-time. Just basically, if there's no spectrum shift, then there's no curvature of space-time is basically what he's getting at here. And we ultimately see that the absence of the spectrum shift in Einstein's theory does not give such refinement to planetary motions in the secular motion of a perihelion, but in the ordinary, and not even in the ordinary Newtonian or Keplerian motion. In short, the orbits of the planets would be straight lines, and the planets would be moving along them uniformly in spite of the sun's presence. The theory stands or falls on the correctness of the results of Evershade and St. John. It is unscientific to assert for the moment that the deflection, the reality of which I admit is due to gravitation. It is in the sense that I declare it a moment ago to be an isolated fact. The discovery made at the eclipse expedition, beautiful as it is, does not in this circumstance prove Einstein's theory. We owe it to that great man over there, pointing to Newton's portrait, to proceed very carefully in modifying or retouching his laws of gravitation. This is by no means defending blind conservatism. The spectral shift required is 100 times, but certainly not less than 40 to 50 times the error of modern measurement. The solar spectrum can even in this country be observed many times a year, and the matter can thus be decided without having to wait years or centuries for another equally advantageous eclipse. If the spectrum shift remains unproven, the whole theory collapses, and the phenomenon just observed by astronomers is a fact awaiting to be accounted for in a different way. So just to recap, if there's no spectral shift, there's no space-time curvature, and the equations used to describe, the perihelion precession and any quote-unquote star displacement can't be, don't have any physical relationship with reality, basically is what he's saying. It's just all for fun and a role play. And to go over the significance of that conversation again, so regarding Doppler shift, i.e. the medium of air, oxygen, and water molecules vibrating facilitates the energy transfer necessary. Let me start over. Regarding the Doppler shift, the medium of air, i.e. oxygen and water molecules vibrating, facilitates the energy transfer necessary to produce the high pitch to low pitch for relative motion Doppler shift in sound waves. Sound waves are produced by the disturbance of a background medium. which causes the particles within the medium to vibrate and transfer energy to one another. In essence, the waves are all waves are varying frequencies of vibrations in their respective mediums. Relativity theory asserts that no energy transfer is necessary to cause redshift. Instead, it proposes that the observed redshift is due to the result of the photon's frequency stretching due to gravitational effects as it travels along the curvature of space-time. To establish a cause and effect relationship between any perceived star displacement during May 1919, or during the 1919 eclipse, St. John's and Evershades were tasked into taking spectral shift observations during the eclipse with equipment that was within 100 times the amount of probable error to analyze such a shift, and the fact that their equipment was that good, and they took multiple observations throughout the year, and they found no such spectral shift, kind of destroys the cause and effect relationship with the displacement and curvature of space time and gravitational fields. They never found any. Yeah, okay, I just said that. Later, we will cover the supplemental experiments that are put forward to reify relativity theory. Pound-Rebka, Pound-Snyder, Heffel-Keating, and these are all cited as proof for gravitational redshift, establishing that a gravitational field can affect electromagnetic energy, in the curvature of space-time and all that. As Silberstein pointed out, without a physical mechanism for the redshift to occur, the equations reduce to just stories. The lack of observed redshift in tandem with the displacement violates causality and destroys relativity theory. Arthur Eddington says to Dr. Silberstein after he went through all that, he says, "One word, Dr. Silberstein, when the result that has been forecasted is obtained, we naturally ask what part of the theory exactly does it confirm? In Einstein's case of the law of gravitation, it is not necessarily that his theory is confirmed with the underlying assumption that the way that they describe the geometry of space-time, so like talking about what the medium of space-time is a quantity measurable by clock and scale. There still remains the question of what that intermediary is, which must be tested by the Fraunhofer lines." So, and that's what we were just talking about. So like dude was saying, they can just use the Venus, going by the sun and seeing if that has any redshift, and it doesn't. So they, and if there was any gravitational redshift due to the sun, like, it would be, you would see it and that kind of stuff. So we'll continue on. So this is November 7th. This is the following day after this big meeting where they produced some really weak evidence and concluded that it was a really strong positive confirmation of the prediction. November 7th, 1919, even though the evidence presented the previous day at the joint eclipse meeting held by the Royal Society and the Royal Astronomical Society was of poor accuracy and presented no accompanying spectrum shift observations to confirm the curvature of space-time as the physical mechanism to cause the star displacement, it was announced by Sir Joseph Thomson, president of the Royal Society, stating that the expedition was a success for Arthur Eddington and that he had proved Einstein's theory of general relativity. By the time Einstein woke up, he was catapulted into stardom and overnight celebrity. British media and U.S. media spreading word of how his theory was confirmed, and the laws of gravitation now obey Einstein's space-time curvature. This is H. von Kubler from Vistas in Astronomy, 1960. It should be noted that the deflection predicted by Einstein in 1916 was very small, being about 1.7 seconds of arc for a ray of light at the edge of the sun, and inversely proportional to the radial distance of the center of the sun. Since no star from which the measurements were made during the 1919 eclipse were within 2 solar radii of the center, the largest deflection that would have occurred, according to the theory, would have been less than 0.8 seconds of arc, which for the 343 centimeter focal length of the telescope used by Eddington would have corresponded to about 0.01 millimeters or 0.000393708 inches on the photographic plate. So even without the spectra data, it's too poor to make any positive confirmations, and even the equipment they were using, it wouldn't even translate to being able to to extrapolate the 1.7 seconds of arc from the photographic plates, according to this guy. This is Dennis Sima in Einstein, the Man and His Achievements, a book that he wrote. The first attempt to test Einstein's prediction was made by a British expedition led by Sir Arthur Eddington just at the start of the Great War. At that time, it was a very striking thing that a group of British astronomers would attempt to test a theory proposed by a German. The results of the test were acclaimed as a triumph of Einstein, and his worldwide fame dates back to that event. Ironically, though, attempts made at later eclipses suggest that Eddington underestimated certain difficulties inherent or uncertainties inherent in such a difficult observation. And even today, Einstein's prediction has not been tested with the precision one would like. So this is in the 60s now, where they've kind of repeated these experiments and tried to see what they could get. And the only displacement they ever get is near the solar limb of the sun. They never get any of that big gravitational lensing, that you would expect, or even like a slight fluctuation. It's literally only in that area where there's a medium, or So John Maddox, the editor of Nature magazine, historically, the dramatic proof that Einstein was on the right track with his general theory of relativity came in 1919, when Eddington and his associate Crommelin took themselves to the Western Pacific to track the total eclipse of the sun for that year. They were bent on measuring the predicted deflection of light from distant stars at the limb of the sun. As the world knows from the prediction was confirmed within the limits of accuracy of the observation to general applause. Einstein became a celebrity overnight. What is not so well remembered is that the measurements on 1919 were not particularly accurate. The standard error for the measurements was roughly 30%, while the displacement on the images for different stars in the field near the eclipse ranged from half to twice as half of the deflection that Einstein had predicted. So the deflection rates were actually more in line with Newtonian predictions, but they just go ahead and say that, Einstein went ahead, banged that out, nailed it. Slam dunk for relativity. Later eclipse measurements have not been much better, largely because the difficulties in making accurate observations and the ad hoc observatories that have to be established to facilitate the conditions necessary to even make an accurate observation like that. So this is Edward Dowdy, who passed away a couple years ago. But shout out to this guy. He wrote a bunch of papers going over the deflection of starlight during eclipses, and he went over the Eddington data specifically. There's a video here that you can reference where he was on Sky Scholar and kind of presented the information from one of his papers. But basically, what he found is that the deflection only happens right here at the solar limb. There's no deflection at all, and there should be, the sun's gravitational field doesn't stop here at the solar limb. So using a different interpretational framework, he's a plasma cosmology guy, I believe, and using a different equation, he basically said that light passing through the plasma medium of the solar limb is what is causing the displacement. And he points out that there's no displacement in any of these. So for those people that require a replacement theory, there you go. This is just a further illustration. Light should be displaced, at different from stars that are different. Just the fact that no light above the solar plasma limbs bends is a violation of general relativity. This is from Ian McCausland, 1999, Anomalies in Relativity Theory. If the findings of the eclipse expedition had been announced as being inconclusive instead of decisive in 1919, general relativity would have had to compete with other possible theories, such as Gerber's, to explain certain astronomical phenomenon. And a better theory might have emerged. In this author's opinion, the confident announcement in the decisive manner of Einstein, the decisive confirmation of Einstein's theory at the joint eclipse meeting was not a triumph in science as it is often portrayed, but it is one of the most unfortunate events in the history of the 20th century. So, what would cause a man to say such a cruel thing about such a brilliant man? Maybe he went through and found out that, this is all based on a bunch of jibber jabber. So to recap, lack of actual evidence. There could be some refraction to explain the deflection. There's no deflection further from the sun than the limb. There's tons of air. If they want to say that the Cromlin observations couldn't be used due to, the temperature changing and that like contracting the plates and making the results inaccurate. I mean, you could say the same thing about Eddington's, and also his data actually gives more agreement with the Newtonian predictions. So by all accounts, so far Einstein hasn't predicted either of the two things that he says that his whole entire theory would collapse upon if it didn't match reality. Conclusions. We often hear math as reality. Despite being able to produce numerous instances to falsify that claim, it is the cornerstone of the relativistic belief system. The mathematical concepts that make up general relativity, Einstein tensors, space-time curvature, were falsely claimed to have physicality to them. Although there is no physical space-time fabric, any bending thereof is conceptual, and the evidence put forward requires it to be, in fact, a physical entity. While there were other possible explanations to the phenomenon, only one was given the stamp of approval, and was seemingly rolled out overnight. We were told fantastical stories about the bending and warping of the fabric of space-time and how space-time can become distorted and collapse in on itself, creating an infinite curvature from which nothing can escape, not even light. Yet it produces no spectrum shift in starlight or from Venus when near the sun. The lack of the spectrograph data is the real smoking gun here. Space-time will later be proven to be a physical entity by the Pound-Repka and Pound-Snyder experiment in LIGO in place of the missing data, but we will get to that later on in the presentation. The issues proving that space-time curvature is a physical entity will become more obvious. So before we move on, does anyone have any questions?
I hope it's just my personal opinion. I hope people, there's 19 people in here. I hope they really appreciate this information. I hope they watch it again and again and pass it on to their friends, because this actually changed my life as far as how I look at things. And so Alan should be congratulated because he came up with this on his own.
That's a hell of an endorsement, Jim, but I didn't come up with this on my own, really. I just kind of found out all this stuff and kind of tied it together, standing on the shoulder of giants, as they say. So, but I appreciate the endorsement and confidence, bro. That's awesome.
My bad for interrupting, too. I thought it was an open forum, so my bad, dude. That was a great presentation. I appreciate it. Thank you.
You're good, man. I wanted to get through because it's a lot to go through. We still got another 40 or so slides. I
concur. Excellent information. I've been talking in the chat, and I'm going to go back and watch all of this. This is excellent. Thank you so much for putting this together.
Cool. Rock on, Alan.
Glad you guys
I apologize for that thing at the beginning, but I just wanted to.
Yeah, everyone's cool. We're all friends.
All good, bro.
Venus, I could see. I was just outside and I was all excited about it because I could see Venus in the sky.
Dude, did you see that perihelion precession, bro? Like, you got your pocket mead with you to make precise, accurate measurements and support relativity on the spot.
Hey, Invisible Man, did you see the precession of Mercury? And
sorry.
Yeah, and that's kind of like even the Venus thing. It just blows my mind that these people think this. Yeah, but I know what you're talking about with the well, that's always been a problem with relativity, was the whole retrograde activity of Mercury. Yeah, so you kind of clarified that even more for me. So thank you.
Nailing it.
That's why they don't like parallax.
Yep. Yeah, there's a whole bunch of other stuff too with stellar aberration and stuff, but I haven't got to that stuff yet. It's actually not even in this presentation. But yeah, the whole everything they say about relativity that they put forward as proof of it is just total. It ends up just body bagging it because it's just lies based on equations to make transformations to reify what they presupposed. All right, so we're gonna continue on here, or just fuck. Okay, yeah, we're gonna continue on here. So gravitational redshift is the next evidence put forward in support of relativity theory. The gravitational redshift of light. Gravitational redshift of light is the phenomenon in which electromagnetic waves, such as light, lose energy as they escape from gravitational field of a massive object. This causes the wavelength in the the wave of the this causes the wavelength of the light to shift towards the red end of the spectra. In the case of gravitational redshift, the energy of light is decreasing, but the speed in which light travels remains constant. The decrease in energy is compensating by an increase in wavelength of light, leading to redshift in the spectrum. The decrease in energy causes the light to redshift. Decrease in energy that causes the light to redshift is compensated by an increase in the wavelength so that the speed of light remains constant. Mathematically, this can be stated as E equals H equals F, energy equals Planck's constant times frequency. As energy decreases, the frequency of light also decreases, which leads to an increase in the wavelength. So it kind of has like an inversely proportional relationship so that it compensates with itself so that it can maintain a constant speed is basically how they describe what's going on. Since the speed of light is directly proportional, in other words, light doesn't change speed. It only changes its wavelength and frequency. The wavelength gets shorter and the frequency gets lower, but the product of the two remains constant, and that product is the speed of light. So that's an overview of how they say light works with gravitational redshift and stuff like that. We'll continue on. How general relativity explains gravitational redshift and cosmological redshift. In general relativity, there are two types of redshift that can occur: gravitational redshift and cosmological redshift. There's also the transverse Doppler effect, which I forgot to include in that sentence. But 1 second. Gravitational redshift. The wavelength of light from an object is shifted towards the red end of the spectrum as it travels through a gravitational field. As the source is, nope, that's not what it says. This effect is caused by the fact that the photons lose energy as they move out of a gravitational well. This loss in energy causes the wavelength to stretch. Cosmological redshift. The wavelength of light of an object is shifted towards the red end of the spectrum due to the expansion of the universe itself. This is caused by the fact that the universe is expanding, therefore the distance between objects is increasing, and the distance between the object and the observer increases. Therefore, the wavelength of light is stretched, is what they say causes that redshift. Now, keep in mind, like, I'm not saying that this is what causes it. This is just the mainstream interpretation of what they say is happening when they look in the sky, and they're applying all this to these equations. The transverse Doppler effect, the phenomenon in which the frequency of light appears to be shifted when the source of the observer are in motion relative to each other in the direction perpendicular to the propagation of the source of light, or the light wave. Supposed to showcase that two observers traveling at relativistic speeds would see the same spectral shift as if they were at rest. In summary, general relativity predicts that redshift can occur due to the curvature of space-time caused by the presence of a massive object, which it explains redshift is due to the energy change of a photon as it moves through a gravitational well, which in case causes gravitational redshift. In the case of cosmological redshift, it is due to the expansion of the universe itself and moving through that relatively changed distance. And before we move on, we'll cover other types of redshift. All right. Other types of redshift. So this is Doppler redshift, caused by relative motion from the source and an observer. Time dilation redshift, caused by the difference in the rate of time between 2 points in space-time. Gravitational lensing, caused by the passage of light through a gravitational field when it bends, which bends the path of light and causes the shift in wavelength. And Hubble shift, light from distant galaxies is shown to be shifted towards the red end of the spectrum, which was first observed by Edwin Hubble in the early 20th century, who found that the light of stars from distant galaxies was redshifted, which indicated that they were moving away from us. Note, even Hubble, up until his final lecture before the Royal Society, always held an open possibility that redshift did not mean velocity precession or recession, but may be caused by something else. Moving forward with the presentation, we'll look at two examples two experiments that are put forward that showcase gravitational redshift, Pound-Repke and Snyder experiments. So moving on to Pound-Repke. The Pound-Repke experiment conducted at Harvard's Jefferson Tower involved emitting photons of a precisely known wavelength at the top of the tower and at the bottom of the tower, which was 22.5 meters. Upon upon measurements, photons emitted from the top and the bottom had a slightly decreased wavelength than at the bottom than what those were than those that were emitted from the bottom and went to the top. So basically, in order for the detectors to work, there had to be a red shift and a blue shift. And what they found basically from their first paper, they titled it "The Apparent Weight of a Photon," because they couldn't distinguish between relative motion redshift and the redshift, the frequency shift that is alleged to happen when light is interacting with a gravitational field. So in other words, it gave a null result. And then the follow-up experiment to that is the Pound-Snyder experiment, where they basically did the same thing, but they increased the length of the tower that they used. And this is from their paper, Effect of Gravity on Gamma Radiation. It is not our purpose. This is a couple years later from the first experiment. It is not our purpose here to enter the many-sided discussion of the relationship between the effect understudy and general relativity or energy conservation. It is to be noted that no strictly relativistic concepts are involved in the in the description of the effect as an apparent weight of a photon is suggestive. The velocity difference predicted is identical to that which a material object would acquire in free fall, equal to the time of flight. So basically, he's saying the relativistic predictions couldn't be accounted for because it was a null result. It was as if gravity acted on the photon and compensated, and made it indistinguishable from the predictions that relativity made for gravitational redshift. And then the view that the local timescale depends on gravitational potential appears to require a coherent source for confirmation. The present experiment is unable to distinguish between frequency change and the velocity changes. For example, it appears that as if an experimental comparison of the clocks at different potentials would make a useful complementary contribution to the overall status of the theory. So here he's suggesting what they did in the Haffel-Keating experiment. But basically these two experiments gave a null result. They couldn't tell anything. And then I have 3 slides going over, there's like 3 different interpretations that people will kind of give to say that, well, no, it actually does prove relativistic effects and stuff. So a common one is time dilation, they'll say. But if you do the math on the time dilation, the effects of time dilation come out to 2.17 times 10 to the minus 21. So the effects are like, and then the effects that were shown in the actual experiment are only of the range of 2.5 times 10 to the minus 15. So the time dilation and relativistic effects that are used just to co-opt the contradiction of the experiment are off by an order of 1 million in terms of their magnitude. So it's not even close. You can't. I mean, like it mathematically works out. You can mathematically extrapolate it, but can you physically? Does it physically mean anything that you can measure? That this is claimed that this would be the measurement. Like you can't do anything with that. So it's just how they continue the role play and ignore the fact that the dudes that did the experiment say, for the second time, that they can't tell the difference between relative motion and the frequency shift predicted by light's or electromagnetic energy's interaction with the gravitational field. And this further goes back to light only bending at the solar limb. So the gravitational fields are assumed to affect light, and here's another classic case where they can't tell if it's affecting light. So we have another null result in regards to proving the interaction of photons and such with the gravitational field. So this whole idea of gravitational lensing, Einstein rings, and all these things, it's just pure fantasy and stories told about the equations. We'll skip through this. So this is the afterthoughts on phase shift. This is the Stark effect and the Zeeman effect. The Stark effect: electric fields such as charges in the environment, currents. Or does anyone have any questions so far? Are we still good? I'm almost done with. Actually, I got a couple more. Let me just power through these. So, the Stark and Zeeman effect. The Stark effect: electric fields such as charges in the environment, currents flowing through conductors of the equipment used to make the detections and measurements of the so-called photons can produce redshift lines via splitting the absorption lines. The Zeeman effect, magnetic fields such as the Earth's magnetic field or other currents flowing through conductors of the equipment can be used to make the detections, can also produce the same thing by splitting the absorption lines. It is for this the reason for the split is that the electrons changing shells move faster if they are going with the field, with whatever the magnetic field or the electric field, than if they're going against it, which they go slower. When the emitting photons, the faster electrons emit a blue shifted photon, and when the slower ones are emitted, when they interact, they produce a red shifted photon. Since these could be traveling in any direction, an observer at a distance will get both varieties. Thus, the single emission line has been split into two lines. The corollary to this rule for emission is that during the absorption, an electron must have to fight against the electric field and can only be absorbed by a redshifted photon, while an electron being accelerated by the field can only be absorbed by a slower moving blue shifted photon. For precisely the same reasons, we should expect to see spectral lines split by a gravity field. The electrons moving up and down through the field should have the same issue with red shifting and blue shifting, but they can't make any positive distinctions. So that's how that works. And these two things are known magnetic or known effects that demonstrate a cause and effect relationship with a magnetic field, causing redshift and stuff. So I want to play this video, but it's going to make me lag out probably. Let me see if I have it downloaded real quick. Okay, so hopefully this doesn't lag me. We're just going to wing it. Let me pull this up on YouTube real quick.
I've made
electromagnetic retardation.
Mm-hmm.
Nice.
All right. Let's see, we got that, and then 618 to 835. Quick speed. So he's going to explain how a magnet and stuff works. If you don't agree with that, that's whatever. Just keep listening, because when he explains the relative motion part, that's what we're looking for.
Remember now, this is red and this is blue. But how can I shift that? Relative motion to the disparity of the electricity, i.e. light, which is a coaxial circuit, transverse electrical, magnetic, longitudinal, dielectric. Let's show you phase shift. Now look closely and I'll explain it. You see how this is blue now? As it was approaching, it went to blue shift. If I move it away, let's just look at this one pole only. Let's ignore this pole over here, okay? You notice this red shifted now? Let me move this closer to a person over here. Let's say there's a person on a little planet over here, and this is a star. Okay, now it's red shifted. Let's move the star closer to this person over here. You see how this blue shifted? Let's move it away and watch this blue, which is bluish green, but it's still blue shifted. Turn to red. Red shift. Blue shift. We're only looking at this pole over here. A second, I think I had a little power outage there. There we go. Blue shift. Red shift. Red shift, moving away from this relative point. Now let's take a look. Let me check my power connection here. Let's take a look at the other pole. Hold on a second. There we go. Sorry about that. Let's take a look at the other pole over here on the right side. Let's orientate my magnet exactly. Okay, let's wait for it to appear. There we go. Let's take only a look at this. Blue shift relative to this person over here. Let's say this point over here. Blue shift. As it moves away relative to this point, we have red shift. You notice how it shifted to the red? Now watch it shift again. Remember, only looking at this pole on the right side of my finger.
Something happened?
Blue shift. Red shift.
Oh, I'm not watching the stream. My bad.
Blue shift. Inverse to the other pole. Look closely. Nothing has changed other than disparity of EM retardation. It has nothing to do with space. It has nothing to do with time. It is EM phase shift disparity or EM retardation. This is also the differential that is programmed into every global positioning satellite relative to its motion. This has nothing to do with Einstein, has nothing to do with general relativity, has nothing to do with quantum mechanics. The universe is purely dielectric and magnetic. If you want to think of it as electrical, that's fine.
All right, so that was Ken Wheeler's 2 cents on how to show, and this is basically, so what I was showing you earlier with the Zeeman effect, actually, hold on, let me go back to the slide. That's basically the Zeeman effect, relative motion through a magnetic field. And so when they look out at this, we live in a magnetic field. So when they look out though, and they see this redshift, they're trying to mathematically fit an explanation into it without accounting for the actual field and stuff like that. Does that make sense? Like they're just kind of hijacking like natural phenomenon and saying that it's relativistic effects and stuff.
And not only that, but look, it proves the globe, like every other observation that they make, right?
Yeah, because space-time gravity only works on, we can form everything into into a sphere or whatever they say, which is hilarious. Okay, so let me make sure that went back. Okay, so that was Ken Wheeler's thoughts on that. Let's see. So Ken Wheeler demonstrating electromagnetism as the physical mechanism for the phase shift in light and the effects of relative motion. When light travels through a medium with a refractive index different from that of air or a vacuum, it experiences electromagnetic retardation, which is caused by the interaction between the electromagnetic energy and the electric or magnetic fields or whatever the medium is. This can lead to a change in the wavelength of light, which results in the phase shift. When a magnet, or that just kind of goes over what Ken was doing, but when the magnet is placed over a ferrocell, the EM field created by the magnet causes the phase shift in light, passing through the field. The LED light around the ferrocell is split into redshift and blue shift at opposing sides of the magnet's north and south pole. While the north pole produces redshift, the south pole produces a blue shift. Moving the ferrocell over the magnet changes reverses the polarity of the shift, causing the inverting the red and blue shift at the poles. So this is a very important distinction because space-time has no refractive index, and the mechanism by which relativity claims that phase shift is induced is because the object interacts with a gravitational field, which is caused by the curvature of space-time, which is bending and warping and all that as light travels through that curved path, as it's allegedly traveling on a straight path that's really curved. If space-time curvature was ultimately the cause of the star displacement, the redshift would specifically match relativity theory's prediction on 1919 or of the 1919 eclipse and any subsequent observations of Venus throughout the year. No space-time redshift has ever been demonstrated or observed, and these observations that would easily establish a cause and effect relationship for the displacement of starlight due to space-time curvature. So if you want to check the Ken Wheeler stuff out, the links are included in the presentation. And this is basically the magnetic field of Earth, and light traveling through that, any other waves traveling through that get retarded based on, are they going with the field or against it, right? That's basically what's happening. So from our terrestrial's perspective, when we're looking up at this or through this, medium, that's this vortex that's swirling, through us and above us and all that, that inherently produces all these effects. Pound, Repka, and Snyder conclusion. Basically that they were a null result, and we'll just read here from this paper, which I have it cited later, not in this slide though. Considering the weakness from the present experimental support for the invariance of C, the fact that the observations of moving sources cannot discriminate between special relativity and the old ether hypothesis, the absence of the speed of light measurement with moving detectors, the lack of experimental validation of the equivalence principle of the equivalence of the source and the observer motions, doubts about the interpretation of the classical ether drift experiments, concerns about the applicability of the modern isotropy experiments, and in fact that all of the unambiguous tests of special relativity in the photon sector have produced no results. It cannot yet be claimed that the local Lorentz invariance of C has been convincingly validated by an observational experiment. So anytime they get a null result experiment and they they apply these transformations to use the equivalence principle to reify relativity theory and things like that, he's saying that there's no actual evidence for that. There's no justification for doing that and saying that light is invariable when experimental observations show that it is. So continuing on with the Heffel and Keating, this is the time dilation experiment that's often referred to as proof of relativity theory. The Heffel and Keating experiment was an experiment in physics conducted in 1971 to test the predictions of Einstein's theory of relativity, specifically the effects of time dilation and gravitational redshift. In the experiment, atomic clocks were flown on commercial airlines around the world in opposite directions, and the times were measured by reference clocks on the ground. And the results of the experiment showed that the clocks that had traveled on the plane had a small but measurable dilation or time dilation effect in agreement with the predictions of relativity theory. So this is their, or wait, is this one? Yeah. So this one is from their original published data that they put out after the experiment. Basically, this is the drift rate of the clocks going. So what the experiment was, they took these atomic clocks and they did one trip around the world going east and west, and they went west to east on another trip, and they were trying to see how much these clocks would come out of sync due to being at a different point of Earth's gravitational field, like at a different escape velocity. How will that affect time dilation, right? Because that's what they say. The closer you are to a gravitational field, the more time dilation you experience. The further away from you are from the source of the gravitational field, the less time dilation you experience. So they were like, okay, let's put these up in an airplane and we'll calculate that the escape velocity of them at the altitude of the airplane, and we'll see if what the difference is. So basically, the clocks became hella invariant really quick. They came out of sync really quick, and the predictions weren't really in alignment with relativistic predictions. And then they made a subsequent release of their work, where they mathematically finessed the numbers and accounted for all the variables, so-called, and it turns out that it actually was in prediction with relativistic effects. So their first one, these are the Einstein predictions in nanoseconds of what the discrepancies would be, and this is the first measurement. Not very close to the predictions, and then after the mathematical massaging, it's, oh my god, it works. So here we compare the original source of data, and this slide here is taken from a paper from a guy who, because they didn't even publish their corrections or like how they derived anything like that. They just said that these are the new numbers after corrections. This guy kind of made up his own thing and reverse engineered it, based on like what it could possibly be, and got the same results. So like, you can just mathematically extrapolate the results of any experiment and apply any necessary transformation to whip it back in line to get relativistic predictions. Just further showcasing that, because they'll use time dilation and things in conjunction with the equivalence principle to verify both theories, which has just been shown to be completely false, or to not have any meaning really, since you can make the results whatever you want. So the Heffel and Keating conclusion: extraordinary claims require extraordinary evidence, and the evidence and interpretations of the Heffel and Keating experiment are anything but extraordinary evidence. You can approach the results of the experiment from various angles to show that the so-called relativistic effects cannot be attributed to it within the confines of a natural process. The time dilation is a physical effect. Time dilation is a physical effect of various factors, which I will now list. Electromagnetic retardation, changes to the medium in which light is traveling. So if it travels through an electric field or a magnetic field, all of these things will cause these clocks to go out of sync. The motion of the atomic clock. And even motion with just putting the apparatus in the plane and the motion of that also makes them go out of sync as well. So there's all these different factors to account for, and they think that they've mathematically reduced it back to, these predictions that go down to like, 0.0000, out to fucking, whatever they need it to be, even if they can't physically demonstrate it, but just through the mathematics of it. So with all these taken into consideration, supposedly only one clock gave a decent reading within the predicted drift, and the predicted drift was just what they were hypothesizing how the clocks would be affected when accounting for these things and their stuff, and it just wasn't even close to what they predicted. It is presumptuous to say that the time is affected rather than the physical mechanism of the device used is falling out of sync due to natural phenomenon. To put it into perspective, to believe the Heffel and Keating experiment supports relativistic time dilation, You must then also believe that a man who lives at the top of a mountain is slightly in the future compared to someone who is at sea level, despite there being no way to quantify that. I'll leave a link in the description for the technical aspects of the Nephilim Keating stuff. Okay. Gravitational waves. So any questions on any of that stuff? Yeah, that was a lot.
Just remember, Alan, the 0.00000736 meters per second demonstrates time dilates. I want you to know, Pound Repka proves it.
Exactly.
That was more of a comment, but okay.
Yeah, exactly. So if there's no questions, we'll go ahead and continue on. So this is gravitational waves. Gravitational waves are ripples in the fabric of space-time caused by the collision of massive objects, i.e., in this case, black holes. They were predicted by Einstein's theory of Einstein's theory of general relativity in 1915, and were finally detected in 2015, 100 years to the day, I think it was actually, by LIGO's Laser Interferometry Gravitational Wave Observatory. The detection provided direct evidence for the existence of gravitational waves and confirmed a key aspect of Einstein's theory. Now, keep in mind, this is just mainstream narrative. LIGO is designed to detect gravitational waves. It consists of 2 detectors, one in Hanford, Washington, the other in Livingston, Louisiana, with a laser interferometer to measure extremely small distances in space-time caused by passing gravitational waves. The laser shoots a beam of light down long tubes, and the warping of space-time caused by gravitational waves rippling through that medium, which nobody seems to know what it is, will cause a change in the relative distance between the beams, causing a detectable change in the interference pattern. By comparing data from both detectors, LIGO claims to have identified measurements matching the signature of gravitational waves passing through the Earth. This is what they use to further continue the proof of relativity theory, the most well-tested and physically proven theory of all time, the greatest achievement of human thought. I have a quick clip from the press announcement I'm not going to play, but it's pretty funny. This guy gives the announcement for the successful confirmation with almost no enthusiasm, just straight dead inside. Thought it was pretty funny. He just says, he just goes, "Ladies and gentlemen, we did it." And then everyone starts clapping as if they give a shit.
You mean like every NASA fake landing was more enthusiastic than that?
Dude, like, it's crazy. This dude's just like, "Hey, we did it again, guys." So he doesn't give a shit. Not that would prove anything one way or the other. I just think the mannerisms of it was funny. On February 11th, 2016, the LIGO Scientific Collaboration and Virgo Collaboration announced the first confirmed observation of the gravitational waves from colliding black holes. The gravitational wave signals were observed by LIGO's twin observatories on September 14, 2015. This confirmed the key aspect of general relativity and provides the first direct evidence that black holes exist and can merge. So yeah, black holes are another thing which I didn't get into in this, but maybe towards the end I'll show you guys what a singularity is. That's funny too. What is not mentioned here is the subtlety of giving the physical manifestation to space-time via the medium which is being rippled in the first place for the wave to propagate, which allegedly causes the interference pattern. This also served as confirmation for the existence of black holes, and more specifically 2 types of black holes that rotate and spin, because if you recall back to the metrics used to describe different types of black holes, the black holes produced by Schwarzschild metrics are stationary, non-moving objects, and the ones produced by the curve metric, the rotating ones that can coalesce and kiss and all that in space, those ones are the ones that LIGO uses to extrapolate their data sets and then run simulations through. Because this is what all this is, right? They've just taken simulations of what a gravitational wave would possibly look like using the curve metric instead of the Schwarzschild metric, right? So they've defined this thing that they think is out there, and then they're like, well, if they collided, that would produce a ripple, a gravitational wave that would be predicted by Einstein's by the equations within the curve metric. All right. So integrity issues at LIGO. So this is taken directly from LIGO's website. Blind injection, stress test in LIGO and Virgo search for gravitational waves. The collaboration knew that the detection could be a blind injection, a fake signal added to the data without telling the analyst to test the detectors in the analysis process. Nevertheless, the collaboration proceeded under the assumption that the signal was real and wrote and approved a scientific paper reporting on the groundbreaking discovery. A few moments later, according to plan, it was revealed that the signal was indeed a blind injection and they were actually on the show Punked. And Ashton Kutcher came out and told them all, you punked or whatever he says. I can't remember. But anyway, that's basically what happened. And now the way that they have this worded is like they knew that there was a possibility that it might be. They weren't actually told that. There's another article that covers it in depth. Oh, it's from this one right here, the Nautilus, the cosmologist who faked it. So to keep it as like a blind experiment or whatever, and to test how rigorously that they would analyze the data sets or whatever. They weren't told that there was a possibility that it could be a blind injection. They went through this whole process thinking it was real. And then like 6 months later, right before they were going to do a press announcement for it, this guy, I'm assuming, came out and said, hey guys, we didn't do it. And like, you know, I guess everyone in the probably didn't stand and clap for that. So that's what happened with gravitational waves. So it's important to note here that in this article, which I don't have pulled up, but you can read it yourself, a small team of people was given access to the LIGO and Virgo's network and stuff on the back end, and just installed like remote access, and basically injected the data and during a test run, actually, because this is how crazy even within the accepted story, when LIGO was booting up, it wasn't fully operational yet, and the stuff that it has in place to stop like false positives and stuff like that, to like rule those out, that wasn't even operating, and they went ahead with the predictions and stuff and act like this is solid evidence for their theory, because this is how thirsty they are, because they spent billions of dollars on this, and it just doesn't do anything, and these people go to work every day and like just pretend, basically. So we'll continue. So that's another thing that doesn't support relativity theory in the slightest. Any questions on gravitational waves or black holes? All right, moving on with the experiments with light that are used to support relativity theory. Michelson-Morley and Aether. Preface. The Earth is experiencing 4 or 5 different vectors of motion ranging from hundreds of thousands up to millions of miles per hour, and all these light experiments are only concerned with the local motion, i.e. the rotation or the Earth's rotation or the Earth's orbit around the sun, the smallest possible velocity when compared to the others. In other words, they're only concerned with in relating the motion of the sky to Earth. The experimental data recorded from Michelson-Morley and continued by Dayton Miller shows an approximate 8 kilometers per second drift. This is the physical mechanism for the translation of motion, of our translation of motion claim. When we say that the translation of motion would cause, if the sky were rotating, how it would translate down and cause things like Coriolis effect and stuff like that. This detection is what would do that, and we'll get into that in a couple more slides. This confirms the absolute reference frame for the propagation of light as well, which is devastating to relativity theory, because the postulates upon which it's built is that there is no absolute reference frame and that they're all equally valid, and light propagates at a invariant speed. But if there's a medium, then there is a speed, and that debunks relativity, because the postulates upon which it's built are just false. So this is why they needed to remove the ether and stuff, or the concept of that, to preserve and show that the Earth could be moving without any detection and stuff, and say that the reason that there was no detection was because light is travels at a constant speed, and everything else relatively contracted in such a way to produce an effect that where you can't tell that acceleration and being at rest are the same from your reference frame if you're in motion. Okay. Ether drift test. It is widely believed that all the early ether drift experiments, e.g., Michelson, Morley, Illingworth, Kennedy, Thorndike, and Jews 1933, the Jews in 1933, all produced a null result, although Miller in 1933 insisted that he consistently obtained an 8 kilometer per second drift velocity over a period of 30 years. So he did 30 years of repeatable, observable experiments, and all these were later discredited by his former research assistant, Shankland. Michelson Morley, 1887, also reported the 8 kilometer per second drift, which is widely interpreted as the upper limit and dismissed because it was because what they had expected was a 30 kilometer per second drift. So they just chalked it up to instrumental error, and they didn't want to deal, like they were just trying everything to explain away why they didn't get their predicted motion. However, Consoli and Constanza 2003 recently pointed out that several of the well-known ether drift experiments actually produced small positive drift velocities. They reanalyzed the original results of the Michelson-Morley experiment, 1887, Illingworth, 1927, Miller's 1933, and Jews, 1933, correcting for Fresnel drag in the experiment medium, i.e., in helium, air, or a rough lab vacuum, in the context of Lorentzian relativity, and obtained a corrected drift velocity of 243 plus or minus 36 kilometers a second from 4 experiments, which corresponds closely to the orbital velocity of the sun around the galaxy, comparable results and conclusions have been presented by Munera in 1998 and Cowhill and Kiddo in 2002. These analyses suggest that the ether drift experiments may in fact show evidence of an absolute frame of reference for the propagation of light. So what they always try and do here is they try and add, these transformation equations to this 8 kilometer per second drift that they, act like they act like is a null result and doesn't exist. But when they try and, when they apply corrections to it and stuff, and they extrapolate something that closely matches what's predicted in the heliocentric model, i.e. the sun's rotation through the galaxy or whatever, they're like, oh, well, this kind of closely works out. Maybe there's a correlation here. And it's like, no, dude, it's just leave it as the detected drift without the transformations. So Michelson-Morley, length contraction and imposing math on reality. Length contraction is invoked by special relativity to explain why there was a fringe shift pattern detected consistent with 8 kilometers per second rather than the predicted 30 kilometers per second. By all accounts, the results of the test the test meant either the Earth isn't moving or there's no ether. They decided to go with removing the ether and using a Lorentz transformation to mathematically imply that the apparatus used in taking the measurements physically shrank or apparently. In relativity theory, the motion of the Earth is relative, and there is no privileged reference frame per its first postulate. An observer on Earth can choose any reference frame in which to describe the motion of the apparatus to create the illusion that the laws of physics are the same in all inertial reference frames. Using the Lorentz transformation, you can show that the amount of the apparatus's length would have had to contract, or you can show the amount that the apparatus's length would have had to contract to give a result not matching the predicted 30 kilometers per second, and then use that explanation to co-opt the results of the Michelson-Morley experiment, claiming that the speed of light is constant and doesn't need a medium to travel, as a medium would cause a variable speed in light, and thus, they would have to accept that there was no rotation detected consistent with the prediction of how fast they say the Earth is orbiting through space-time. Because of this relative length contraction and dilation of physical reality, relativity theory is entirely dependent on the speed of light having an absolute speed so that it can be used to measure everything else relative to it. Since in relativity theory, length contracts and time dilates. The speed of light in a vacuum provides a new unit of measurement to measure time and distance within space-time geometry. To quote Louis Essen, the contraction of the length and dilation of time can now be understood as representing the changes that have to be made to make the results of the measurement consistent. There is no question here of a physical theory, but of a new system of units in which c is constant and length and time do not have constant units, but have units that vary with v squared divided by c squared, which is part of the Lorentz transformation. Thus, they are no longer independent, and space and time are intermixed by definition, and this is not a result of some peculiar property of nature. It's purely imposed by the mathematical stuff. So I added the last part of that. His quote ended at nature. That's basically what he's saying there. There's no observable phenomenon or reason to do this. It's just strictly in the math. And the way that they do this to explain the results kind of reveals the fact that this isn't a framework that describes, what's actually going on. It's just math to reify itself. If C were ever shown to have variance, and this Lewis Essen guy, he's the guy that invented, real quick, he invented the atomic clock. He was a big proponent of relativity theory. He taught it. He was a professor at the University of London, and he was a member of the Royal Society. When he retired, he started looking into relativity theory, with a more critical eye, I guess. And he actually completely turned on it and said that it's complete horse shit, and published a bunch of stuff, discrediting it and talking about it. He started a magazine called Galilean Electrodynamics, where he just dunked on relativity theory, and just completely saw the light on it. And really, really interesting stuff there. So that's coming from this guy who former big proponent of relativity theory, right? Like this isn't just some guy who, picked up a newspaper and, decided to have a real strong opinion. He actually taught it, lived it, loved it, thought it was the best stuff ever. And then he started realizing that it's just based on, complete fallacies and backed up by nothing. And it's contradictory to all observable reality. If C were ever to be shown to have a variance, or there would be an ether, or if there were to be an ether detection, the ether would serve as the new absolute frame of reference, and that would falsify relativity because it would show that the postulates upon which the theory are based on are false in nature. The reason that the reason that there can't be an ether in the theory is because it would cause a variance in the propagation of light, changing its speed. And a quick reminder on relativity's postulates, or special relativity's postulates specifically. All inertial frames are equally valid, and the second postulate is that nothing can exceed the speed of light in a vacuum. When we're asked about physical mechanisms to transfer motion to the Earth from the sky, or what the physical mechanism for propagation is of electromagnetic waves through the ether is, so just to cover the translation of motion, the physical mechanism for the translation of motion comes from an 8 kilometer per second drift of which are shown by the results of the Michelson-Morley experiment, further backed up by Dayton Miller and 30 years of his repeatable experimental Michelson-Morley type test and data, which has been analyzed by physicist and Nobel Prize award-winning economist Maurice Elias, who did a statistical analysis on Miller's data and found that the results were not due to a temperature or instrument error, and that Miller had detected a gradual change throughout the year, and that the fringe shift reached their minimum and maximum dimensions right at the equinox is a direct, undeniable refutation of special relativity. And then this last part's a quote from Whitsitt, who really eloquently described that Miller's data. I thought that was really good to put in there. Supposing a gradient in the motion of the medium, translation of the motion from the sky. I'm sorry, let me start over. Supposing a gradient in the motion of the medium, translation of the motion from the sky or from the rotating sky would produce things like the Coriolis effect, i.e. storms rotating in certain directions relative to their location on the plane, standard atmospheric pressure, i.e. uniform distribution at the surface, decreasing in altitude, or as altitude increases, would provide the mechanism for the gradient of motion that's being translated from the surface, or to the surface, sorry. And then the mechanism of propagation of light through the ether. We don't actually know how that works, because the theory was abandoned for space-time nonsense. But basically, the way that they used to theorize about it was that works similarly to how light works. I mean, how sound waves work, how it's vibrations of the molecules in the medium, and that's allowing it to propagate through. So similarly to how there's an energy exchange between air and the water molecules, with sound waves, the ether provided the mechanism for light and spectral shift, causing red and blue shift. So that's basically how that works. They act like it's a big gotcha moment for like if you can't explain the mechanism. And it's like they don't even have a mechanism for redshift, but they act like they do. So it's like one of those completely inverted things where it's their position that doesn't have that doesn't have a thing. And then here's another Witsit quote: I can wave my hand, but I can't hand you a wave. So that's a really good way to describe it, because a wave is what something is doing. It's not what it is. But they kind of have people in this mindset that the wave is the thing, like it's this particle, duality traveling and all that stuff. So they kind of give it, it's kind of like cloaked in this metaphor that's kind of misleading about it, which is, so anyway, here's a quote from Witsit's slide recently on a presentation he did. If Dr. Miller's results if Dr. Miller's results should be confirmed, then the special relativity theory, and with the general relativity theory in its present form, falls. Experiment is the supreme judge. Only the equivalence of inertia and the weight remain, which would lead to an essentially different theory. Albert Einstein, Science Magazine. So if Dayton's Miller were to be confirmed, then there would be his Einstein's theory would be invalid, because there's an absolute frame reference. Light has a variable speed. Everything that this framework is built upon to describe the distortion of space-time geometry, to use geodesic or orbital paths as the explanation for how things travel, just completely falls apart. And that's what that's what that Dr. Silberstein was getting at. This is what it's always been about. And they just cover this all up and act like we're in the wrong for questioning it. So another thing on Lorentz transformations, we're almost done, guys. I know it's been a long one, and thanks for hanging in there. We're close to being done. Lorentz transformations. Length contraction, also known as Lorentz contraction, is a phenomenon predicted by relativity theory, where the length of an object moving at high speeds appears to contradict the direction and motion relative to a stationary observer. While it is considered to be a real optical effect today, there have been no direct experimental attempts to test its occurrence in nature, and it's unobservable in practice due to the breakdown in the concept of simultaneity. Initially, it was thought to be a real mechanism or a real physical deformation of the atomic lattice structure of solid matter, but this was later relaxed only to invoke the appearance of contraction. In short, the Lorentz contraction or the Lorentz transformation cannot be measured because it would have already happened in the observer's frame of reference. If you already assume that the observers are in motion, you can create an unfalsifiable mathematical framework of interpretation, because when you apply the transformations, that explains your presupposition, and anything that disagrees with that can be mathematically explained via conceptual ideas rather than physical mechanisms. In short, because the observers are assumed to already be in motion, e.g., Earth's alleged orbit around the sun, they cannot measure the physical contraction directly. Instead, they must extrapolate that it has already happened based on the mathematical transformation they apply, to use their contradictory observation and experimental results to confirm relativity theory. Belief in the unconfirmable transformations is fundamental for accepting relativity theory. That's the explanation of what's going on with transformations. Some more detail on that. This is the saying Sagnac effect. Sagnac effect is an observable phenomenon in which the travel time of light is affected by the rotation of a platform. It was demonstrated in 1913 by Georges Sagnac using a rotating interferometer, and has since been used in many applications, including fiber optic gyroscopes. The effect is based on the fact that the speed of light is constant in a vacuum, but varies if it's moving in a medium. When light travels in the opposite direction around a rotating platform, the difference it travels in time is a result of results in a phase shift in the interference pattern. The magnitude of the phase shift depends on the angular velocity of the platform in the area of the enclosed by light's path. The reason it contradicts with special relativity is because it shows the speed of light changes due to a delay set by the background medium, and that's that's intended. That's intended. That doesn't make sense. Keep going. Oh yeah, so Michael Bowden has a video on it explaining the Segnek effect. Highly recommend. Gives a really detailed breakdown of what's going on with it. So continuing on with the Segnek effect. While the classical Segnek effect appears to conflict with special relativity, it is argued that the rotating instrument is a non-inertial system to which special relativity does not apply. An observer viewing the rotating experiment from the inertial frame would be permitted under the rules of special relativity to measure relative speeds that differ from c. So the apparent speed of c plus v and c minus v of the counter propagating beams in the instrument frame would still be consistent with special relativity. So they're saying, there's an observed variance in the speed of light, but because they're classifying the Segnek effect to take place in a non-inertial reference system, their special transformation coordinate system doesn't apply. However, Wang and others in 2003 and 4, Wang demonstrated that the Segnek effect in a non-rotating inertial reference frame using a fiber optic linear motion sensor interferometer, they showed that the light travel time in a straight optical fiber in inertial motion has a first order dependence on the fiber speed in a local stationary frame, just as the light travel time in the rotating Segnek effect. Rotating effect fiber optic gyro, which has a first order dependence on the tangential rotation of the speed of the fiber. If the Segnek effect can be produced by inertial motion, then the rules of special relativity would have to be applied after all, and the linear Segnek effect experiment would violate special relativity. So another experiment using the Segnek effect has, destroyed it again. And I have a video kind of showcasing what the Segnek effect is. It's basically the same thing as the Michelson-Morley, except the apparatus is rotating, and the relative motion of the deflection plate is what they, gives an increase in time, which is basically saying that light doesn't travel at the same speed, regardless of motion, because they can't add or subtract anything to the speed of light, because that would violate their postulates. And that's what they're saying here. This is why we're trying to classify the Segnek the laser optic gyro as a non-inertial system to avoid that. So now continuing on, this is the Ives-Stilwell mainstream interpretation of this experiment. The Ives-Stilwell experiment was conducted in 1938 by Herbert Ives and George Stilwell. It was designed to test the time dilation predicted by special relativity, or by Einstein's theory of special relativity. The experiment involved sending light waves through a moving glass tube with hydrogen gas, and the tube was made to move at high speeds using a motor, which caused the waves to experience a frequency shift. The frequency shift was measured using an interferometer. The results of the experiment showed that the frequency of light in the light waves, the frequency shift of the light waves was indeed in agreement with the predictions of special relativity. Specifically, the experiment demonstrated that time dilation occurs when objects move at high speeds relative to each other. The Ives-Stilwell experiment provided further evidence for relativity, or for the validity of special relativity, and helped establish it as a cornerstone of modern physics. So again, mainstream interpretation is what that was. So they had this gas tube attached to a motor and a track, and they accelerated it, and they looked at a laser beam that was going through the medium that filled the tube, and they extrapolated from the interference pattern that special relativity was true. This is from Daniel Bizzari. And I referenced this paper quite a few times throughout the slides. This guy goes through all these classical effects and just bangs them out. So I figured, might as well include him. So referencing this guy again, Ives and Stillwell, 1938 and 41, performed a second order Doppler experiment that was intended to be a demonstration of time dilation. They measured the longitudinal Doppler effect in red and blue shifted hydrogen beta line emission from hydrogen atoms moving at up to speeds of v equals 0.01 of c. Simultaneously in approaching and receding directions, essentially the same effect in neon was investigated by Kaivola and others in 1985, and McGowan and others in 1993, but the results and their interpretations are also problematic. While it is true that the observed red and blue shift are slightly asymmetrical in the relativistic case, they are also asymmetrical in the Doppler or in the classical Doppler effect for moving sources. Only in the second order effect only this second order effect is actually twice as large as the classical case that it is in the relativistic case. So the detection would be easier in the classic case. The existence of an asymmetry does not necessarily mean that the observed effect was relativistic. So again, they're just co-opting, they make an observation and they're like, oh, it matched all these predictions, but it also still matches the old framework of interpretation, the old classical mechanics where, lights or electromagnetic energy is propagating through a medium, right? It still matches all of these things. So Kundig, 1963, and Hasselkamp, Mondry, and Sharman in 1979 claimed to have directly observed the relativistic Doppler effect. However, the results and interpretations for both frameworks is problematic. Kundig's Mossbauer rotor experiment was recently analyzed by Kolometsky and others 2008. Hasselkamp and others did not initially detect a transverse Doppler effect, but had claimed a detection after correcting for possible misalignment. So, and then furthermore, it is a little known fact that the classical transverse Doppler effect is observed in acoustics, which would suggest an analog in the classical wave theory of light, although no such effect is described in textbooks. So this guy is pointing out that everything still works in classical mechanics and explains it just as well, and they don't even talk about it anymore. So, and the only proof that they were able to extrapolate out of these experiments is, when they make corrections to it, when they apply transformations to it, when they make these assumptions to reify their position. And this is a list of this is a list of a bunch of different experiments that are analyzing light in similar ways, trying to test for relativistic effects. And they all require, their own unique interpretation and different explanations on how light works to make it fit relativistic effects, even though a lot of them are in direct contradiction to relativistic effects. That's the end of the experiments with light, and I'm just gonna read in closing, and then we'll take some questions if there are any. How math became reality. Conclusion. In conclusion, the historical and classical experimental evidence put forward as proof of relativity theory does not support it, and the theory should entirely collapse on itself at free fall speeds, and has been revealed to be a mathematical prank played on us all. In my opinion, there was a deliberate effort to promote the theory of relativity and make it widely accepted. Someone or some group of individuals realized that they could use the framework of interpretation of space-time curvature to manipulate the concept of time in nature in natural electromagnetic phenomenon. This was done by using space-time metaphors supported by mathematics. The terms space-time or space-time curvature are misleading and imaginary. There is no experimental proof that relativity theory is anything beyond a mathematical framework. Space-time possesses no physical attributes and cannot distort time or alter the path of mass or massless objects moving along the non-existent curvature of space-time. Some individuals may think that the theory of relativity has been verified because its predictions have been validated on several occasions. However, other concepts like Lorentz's ether theory also produce comparable or comparable outcomes. The issue with the theory of relativity is that it employs mathematics to make successful predictions, but the way it describes time and space is illogical and even goes against all established knowledge. The underlying problem arises from the switch from Lorentz's concept of absolute time and the variable speed of light to Einstein's idea of relative time and the constant speed of light. The Sagnac effect demonstrates that the speed of light can vary based on the observer's position, which appears to make time pass differently. The major difference between the two systems that Lorentz's system implies is that the stars, planets, and galaxies and other celestial objects are closer to us and are and exist in a denser medium. In contrast, relativity theory is essentially the inverse of the ether theory of an ether theory of a closer and denser medium, which allows for a broader range of interpretation concerning the distances and sizes of objects and the nature of the so-called vacuum of space. The reason why mainstream science can state with a straight face that a photon has traveled for 13.7 billion years to reach our eyes and has covered 80 sextillion 600 quadrillion miles is due to that inversion of the constant speed of light and relative time. Experiments should guide the progression and validation of theories rather than the theories influencing the results of the experiment so that the data can be selectively used to confirm the theory. So this is how they turn the extended plane into a three-dimensional oblate rotating oscillating spheroid by reverse engineering everything and making it fit their presuppositions. And this is the source page. So all sources are available to download here. And in the newer slides that I added, I just added the PDF to the actual slide. You can just click here to download that if you download the presentation. So that's the whole story on it. If anyone has any questions, thoughts, critiques, hit me up. I'm available to hang around and talk for a little bit.
Hey, Alan, I have a message from the crowd who listened. Just a second.
Yeah.
Yeah, that was great, man.
Ooh, thanks, man.
That was great. I've never seen it actually in its full totality from beginning to conclusion.
Yeah, you were on Troublings for the first half of it. But yeah, at the conclusion, it really kind of brings it all together and solidifies that they got nothing, man. It's all just lies and transformations.
Is this conclusion all your own words?
This? Yeah.
Yeah. Yeah, it sounded awesome, man. Definitely some high level conclusions drawn, right? Some extrapolations that I think we all would agree with.
Yeah, it's a dense topic or whatever, but I tried to break it down and make it, digestible or whatever. So like I said, this is like hands down an absolute body bag to relativity theory. So if anyone, has any questions or, needs something else explained, feel free to hit me up. All my contact information is available here on the first slide. I'm on YouTube at space_audits, on Telegram at space_audits, Discord, Alan #3658, and email alanspaceaudits@gmail.com.
I also threw the PDF version of it in chat for everyone.
Oh, thanks. Is Rob still here?
No, he was gone like an hour and a half ago, but he did ask for the recording. So
okay, cool.
Hey, Alan.
Yo, what's up?
Hey, nice work, man. This is Chris. I just want to let you know, man. Hey,
Thanks.
What up, bro?
Thanks, bro.
That was a great summary of the strongest refutations of relativity that we have record of. Yeah, mad respect and appreciation for the presentation. And I just kind of wanted to add there. I presented some of this and the most common in like debate formats and stuff. And the most common objection that I've gotten personally was that because, of course, they can't refute the actual data or the actual, conclusions that are drawn. So they'll just say, or a lot of times they'll fall back on, oh, well, you haven't done these experiments. This isn't evidence for a stationary topographical plane. This isn't your evidence. But I just kind of want to make it absolutely clear to, just to kind of summarize what you just presented there, is that like this is at the very foundations of relativity. So like this is what their model was built on. Like without these experiments and observations and quote unquote confirmed phenomenon, the perihelion precession of Mercury and their conclusions on that, Michelson-Morley, the invariance of C, redshift and the bending of light around massive objects. Without that, they literally do have nothing. I mean, this is like, as Witt has said many times, gravity is literally the glue that holds their model together, and relativity is gravity. And without that, their entire model falls apart. So even if they don't want to concede that, oh, this is evidence for the stationary topographical plane model, it at the very least leaves them without a model, full stop. So anyways, just great presentation on the evidence. I really enjoyed it.
Thanks, Chris, and well said, man. Really appreciate the what you said there.
So
yeah.
It looks
Oh,
like
that's the Chris. Oh, I see. What's up, Chris?
What's up, man? Good to be hanging out. First time on Discord. Alan brought me on here, so
Yeah, welcome, man. This is where all the
Yeah,
cool
man.
kids chill,
Yeah, it was
I
worth
got
it to
here
stop
late.
by, man. This is how you guys get down.
I got here late, Alan, but you crushed, bro. Like I just saw the end, unfortunately, so I'll have to like watch it back or something. Yeah.
Oh, hell yeah. Thank you, man. Appreciate that.
Yeah, that's cool, man.
Alan, how many slides? You started out with 64 and you got 82, so you had quite a bit.
I added a couple throughout the week. Like I've been motivated to, or I've been wanting to get motivated to add stuff to it that I figured out since the last time I presented it, but I just kind of was like, very lackadaisical with it. So when I put the a time limit on it to do the presentation, I motivated myself to get in there and add all those extra slides.
It's amazing how that works, right?
But yeah, I went hard over the last couple of days, dude, because these are all recent slides. Like that's why I was kind of fucking up on reading some of them, because they're all like literally a day or two old.
I think what's fascinating is if you want to destroy heliocentrism and special and general relativity, this is a must watch, along with geocentrism and Schooling the Globers Part 3 that Austin did. So if you ever, you want to spread the word around, have your little library to destroy special and general relativity, those are 3 great sources to do it.
Yeah, I'm gonna make a link of or a playlist of like things that really bang out relativity theory, and also Chris has a great paste bin link of all kinds of video references to different videos that debunk different aspects of things. It's really well organized. Chris, if you have that link or whatever.
Yeah, I got it. I can drop it in the.
Yeah, post it in the live chat. Not the. Post it. You'll figure it out.
Yeah. I'm super boomer tier when it comes to like new platforms and stuff like that. I don't do social media like at all, but yeah, I'll figure it out.
Yeah, post it wherever you post it, and the boys will take care of it for you.
Hell yeah, dude. Thanks for the shout out.
Yeah, but yeah, that's a really good comprehensive list. And yeah,
that one's got all of Witset's schooling the like. I really enjoy Witset's debate reviews and kind of breakdown of his strategies. There, he goes into, especially with Michelson-Morley on a couple of the earlier Schooling the Globers episodes. Those are like a must watch for anybody who's looking to get a comprehensive understanding of kind of just the baseline, like where relativity comes from, why they even make the claims they do, and of course like how the very data that they use to try to substantiate their theory can be used against them to show that it's completely nonsensical and just utterly retarded. But yeah, I'll put that in the
it's like chat. Impressive sleight of hand if you think about it, because the very evidence that refuted their position they tout as evidence for it.
That's what makes it so hard. That's what makes it so hard to overcome, is because like that Blitz guy in that debate the other weekend, he was referencing Pound Snyder Pound Rebka as evidence for relativity, and it's a null result. It doesn't give any distinction for relativistic effects at all. And like I was saying, all the classical wave theory mechanics still explain everything just as fine. It's like
So
they just don't talk about it.
I
Well, I'll
think
watch this back. I would love to look through this because I came back and forth a couple times because I had to like do something, but
Yeah.
the little bit there was definitely stuff I heard that I did not know. So I would love to familiarize myself with it for sure.
There's a whole PDF of his printed PowerPoint that's really clear and cool to look at. Actually, it's a really nice like walking away present, I think.
Yeah,
So this-
I'll post it in your Discord. What's it?
So this whole thing, this whole thing of May 29th, 1919, it's been shown to us to be the bending and warping of space-time, but it could just be light passing through the medium of the heat of the sun, and that's why you don't see it anywhere farther out from the sun.
The big secret is that light doesn't pass through anything. Like
yeah,
it's just there, bro. Like it's just there. It's not even complicated. I mean, I mean, light's just there, and we see an excited version of what we call light. You know what I mean? Like that's the only thing I disagree with the fatherheads of electrical field theory. They seem to kind of cram propagation down light's throat, where it doesn't seem to permeate space. It's just already there.
I think we've learned through Austin that light is spontaneous, and of course, anybody who believes in the outer space, religion, their fairy tale, knows that thinks it's 186,000 miles per second, where we basically know that it's spontaneous.
Yeah, so like that's why the invariant speed of light is a good point, even though there is no speed, because like that's the first step to getting someone to understand that the constant is wrong, right? That the speed of light is actually variant. So like that's actually a rate of induction, that's perceived illumination rate. But I mean that's like the big boy leagues. Like
so E equals MC squared is totally debunked by that.
Yeah, because there's no C, but there does seem to be a intrinsic connection between matter and energy, though, and even Tesla would say that. But of course, that's all Einstein did was hijack everyone else's stuff and then bastardize it with pseudoscience. But I think so. I think energy and mass do have an intrinsic relationship. In fact, they're just different versions of the same thing, in my opinion. But it's all ether.
That's first law of thermodynamics. It's just basic. Yeah.
So energy cannot be created nor destroyed, so that means it's transferred only, which means it's transferred from where? And where's energy transferred from? It's the background medium, it's the pure potential state of all of it. But like, Alan, have you ever seen where they did? I don't know if you mentioned this in this because I didn't get to see a lot of it, but like where they used coaxial cables and they achieved 3C.
I've heard of that, but I haven't looked into it. I think I heard it from you, and I lost the thing you referenced. I couldn't remember.
Yeah, I can drop paper.
Yeah, hit me with it. Yeah, that's hilarious.
Yeah, it's crazy. They achieved 3C, and then that author, he comes back with the paper later, and he's like trying to do mental gymnastics to explain his own results away, and he tries to save relativity, basically crams simulation theory down the results' throat to save relativity. Like literally simulation theory, like there's this inexplicable simulative, relationship between light and the world.
The old simulative relationship.
Yeah, man, it's pretty crazy. So I think that's very interesting. I think Flat Earth would, dude, if we would just come together and do the experiment and show 3C, it's like, yikes, that's brutal. Not that it's needed, but
not that it's needed, but it would be some nice icing on the cake.
So
that is the next step. Yeah,
technically you could get 3000 C, right? Because light's just already there. So in theory, you can get a quadrillion C, because all you're doing is getting closer and closer to instant. Now it's hard to even conceive of something like that, like 3000 C even, right? Like, what does that mean? Because the speed of light seems to be pretty much instant anyway. But you could multiply it infinitely to get to instant. There is no limit to it because it's already there. So, but like I said, that's like That's more advanced. Like, I think that's like a very deep, that's like drowning in profundity. We're talking to people that are like, oh, mass attracts mass. So it's yeah, it's best
well, and
stick with the speed of light construct and explain that it's not invariant.
I haven't read any of the papers you posted with it, but I know you're extrapolating them wrong. So I think that's what we're dealing with.
And for these purposes, like for the purposes of talking to Globers and stuff, like it really is like you're completely right. Like the next step is, getting these experiments down and getting our own data, getting our hands on the information and conclusions that we've tested ourselves. But for now, like it does suffice to say, look, using your own data, kind of as if you want to call it a hostile witness or whatnot, using the data, the very data that they use to construct their model, when you parse it apart, you can basically show that no, it's actually a refutation of their model. So like that's at the very least you can get them to kind of get them cornered with that. I mean, they admittedly in their own model have denied mass attracting mass, and so they were forced into the curvature of space time and whatnot. And as this presentation perfectly illustrates, like that's nonsense as well. So this is pretty good just for the baseline of showing them that they do not have that their model is nonsense. It doesn't work.
Shout out to Chris for stationary topographical plane, saying it a couple times at the beginning. Congratulations. That is
I'm trying to make I still catch myself every once in a while with the flat, but I do think that it is important to be concise and clear with your words. So I've tried to make the switch to enclosed stationary topographical plane. I think all of those words are well substantiated by the evidence.
Yeah, that's like the most irrefutable phrase.
Right.
Yeah.
If you break down stationary, Michelson, Morley to Dayton, Miller, topographical, obviously we are, and we're generally plane. So if you say stationary topographical plane, you got it. You got it, man.
Yep.
I put enclosed in there as well.
Yeah, enclosed is good as well. Yeah. Like
enclosed is one in my percent. I mean, in my opinion, you can't get much closer to 100% proof that we're enclosed than that. I always reference this, but the pressurized box in a vacuum chamber experiment, thought experiment, if you will, whatever. It's undeniable. It's objective. High pressure moves to low pressure, but that alone right there, it's enclosed. I mean, you can't. And then, as Whitsitt also has stated multiple times, the equipotential increase that you can't, unless they can provide an example of that happening without the use of two Gaussian surfaces. It's like, how are you going to deny enclosed? Just like with when they say, how do you measure for stationariness? It's like, well, you measure for motion, and every time we measure for motion, it's proven that there is no motion to be detected. Well, that's a pretty good indication of stationariness. Just like with the enclosed part of that phrase, you can do the same,
Good point, man.
Yeah, absolutely, dude. I've never heard a rebuttal to the Gaussian surface thing. Like never. Like to have equipotential, you have to have a surface above and below. I've never had a rebuttal.
Yeah, that's a really good one. I totally forgot about that one.
That's a shout out to Bob for that. Bob brought that to my attention. Yeah.
Yeah, I think it's real important. We need to, obviously heliocentrism depends on 30 kilometers per second around the sun. And if we understand that Michelson, Morley, Dayton, Miller, and beyond gives us 3, 5, 8 kilometers per second, if we understand that it's the sidereal rotation of the guy translating down to the ground, which it can explain slight Coriolis effects and things like that. If we can actually get that down in our conversation, we destroy the motion of the Earth around the sun.
Yeah, well, as I was talking with Alan about it the other day, and it's funny. The funniest part about all that is the 30 kilometers a second orbital velocity around the sun shouldn't even be the most detect. You know what I mean? You still got other vectors that we're supposed, the entire solar system's traveling, the entire galaxy is traveling. Those should be apparent far before you see the 30 kilometers orbital velocity. So.
Dude, I actually have a lecture from some Ivy League professor, and he's talking about that specifically. He's like, it is strongly disputed that the primary detection would even have been the orbit. It would have been the motion in the galaxy. It would have been the galaxy rotation. So like they didn't even account for that because they didn't even know about that, right? Like that wasn't like an accepted value. So now there's this whole new value that's way greater. Michelson-Morley should have detected our alleged motion through the galaxy around the galaxy center, and that's pretty profound. Now that's a big number.
Professor
I have a lecture somewhere. I'll have to find it.
Yeah, even Professor Park said the other night, whether it was last night or the night before, he said it was 220 kilometers per second, for all the vectors.
Yeah, dude. I invited him to the server because I was like, oh, there's a glober that I forgot to bring here. I kind of want to talk to him, and he immediately joined in and was listening to your whole presentation. And like when he started talking about him, I was like, ooh, I don't know if this changes anything, but he's here.
I didn't say anything bad about him. He was doing the.
No, I know.
Yeah, he was about to do it, and I just cut him off and started presenting this stuff to him. And, and obviously it's not fair to just drop all this on someone mid conversation and then expect them to walk back relativity or whatever. So I wasn't.
It's totally fair. It's totally fair. Did you proceed to tell him that you were going to dunk on it? Did you give him a copy of this?
Well, dude, you started engaging with his text chat, which I thought was kind of like, oh, you don't do that. Like, just leave him alone. Don't give it voice, because no one can see that on the stream.
Yeah, that's why I kind of stopped getting away from
PDF.
Him. Yeah, well, he has access to it.
We're giving PhD's homework assignments.
I'll send it too. Yeah, I know, right?
For real though, because I gave him the paper from Constantine Mice that I don't even fully agree with, but just takes their stupid little model and crams it, down their own paradigm's throat. What can they do with them taking their own pseudoscience and then showing why it's wrong? He's supposed to be reading that paper, which is about, the quantum electromagnetic energy density of a vacuum and the electromagnetic nature of a vacuum and blah, 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 mass charge equivalence. You get it. So he's supposed to be reading that paper, getting back to me. You might as well just add another homework assignment.
Add another homework. Homework for the Globers.
For real, because he's one of the more
he is a chill dude.
Yeah, he's like at least it's possible.
Gets back. Yeah. And then Flack, if you're there real quick, you know how you were asking me about how they have to bring it back to relative motion and stuff. They do actually do that with a surprise transform equation, which I'll show you here in a second. if you're still there.
Surprise! We have a transform equation for everything.
And I went to the library today and picked up this little puppy, quantum mechanics. I am definitely hooked on this physics stuff. A lot thanks to you, and of course thanks to Alan too. But thanks a lot, guys.
Yeah, cool, man. I got so many books I can't even. I'm so behind, dude.
I know I got so much stuff to read. It's where do I even start sometimes,
And maybe AI is not so bad after all, huh?
Dude, it definitely gives a gameplay boost to determining if something is worth reading.
Well, did you know there's actually there's a specific site, I forgot the name of it. You can actually drop information in it and it'll make a presentation for you within a minute.
Oh, Jesus. All right, cool.
I can tell you that right now, but if you had given it but you want to boil it down, right?
Right,
obviously.
Right.
But like I'm saying, it'll just do the aesthetics for you real fast. Because it sucks. I have all these PowerPoints I have to do. I'm not gonna make one for every debate, but I'm like, oh wow, the computer will do it.
Yeah, that's tight.
We should start using AI. They're like, Austin, why don't you have an entire model of the universe from the biggest to the smallest scale?
I use ChatGPT to verify a lot of the mainstream aspect of what I was talking about to make sure it's actually correct. So I don't think there's a lot in this presentation that's actually too far off of what they actually say, how it works and stuff.
No, it's good.
It's a great tool. This presentation is hella consistent with what the mainstream narrative says.
Yeah, the little I heard where you're saying their mainstream position, I'm like, oh, dude, if you said that out loud in a room full of these Globers, they'd be like, yeah, so you know the answer, right? They would immediately believe it. So
yeah,
they know it's good. Yeah.
So, Alan, what's your next project?
Nothing, man. I'm about to take a little break, take a little breaky poo, man. I've been going hard at this.
Austin. Alan posted a 21-page PDF on his Telegram, which is really, really good. And it's a shorter version of what we saw tonight.
What's that?
I think you posted on your Telegram a 21-page PDF.
Oh yeah. It's basically the presentation, but in PDF form.
Yeah, smaller form, and it's really if you don't want to go through 84, which you certainly should, the 21 is really good.
I want the whole thing.
Wait, the PDF should have all the slides. Yeah, it's got all 80 of them, Jim.
Yeah, it's cool. Yeah, Alan is my science advisor.
Nice.
So, any more questions for Alan before we end off the stream? We hit like 3 hours.
Yeah, let's go ahead and wrap this up, boys.
You work for the CIA, or are you like control app or something?
I'm thinking if I gotta put this on my BitChute, no one's gonna watch it if we go much longer.
Are you just trying to get our trust so that you can lure us in and you're actually like controlled app?
Well, I'm actually gonna have you guys give me money at some point, but don't blow the secret.
I have my paycheck directly deposited.
Accepting donations up top.
Yeah.
Conclusion, Alan, have you, with all of your thorough research here, did you discover any substantial evidence that can only be explained by relativity?
No, quite the opposite, actually. Everything is actually explainable by classical wave theory, with the assumption that there's a medium. Yeah, this guy talks about it in referencing the Ives Stilwell experiment. He points out that furthermore, it is a little known fact that the classical transverse Doppler effect is observed in acoustics, which would suggest an analog in the classical wave theory of light, although no such effect is described in textbooks. So
that was such an eye opener. That was such an eye opener to me, Alan, when you hit me with that info about redshift needing the medium for energy to be transferred to as well. And it was kind of like one of those aha moments, because I had been really looking into the laser interferometry experiments and realizing like that conclusion that, hey, there has to be a medium, and the very data that they're using to claim that that supported their model, it actually supports the obvious reality that there's a medium that that light is is traveling through. It's but I never had thought to kind of cross that over to redshift. And it's like when you kind of summarize that to me in like a quick couple seconds, and I kind of got it. I was like, oh my God, he's right. Like, how are you going to have redshift without a medium? It is required in order for the phenomena to even take place.
Yeah,
so
and that's
nice
actually,
job on that, man.
And that's something that actually Ives himself argued, because this guy was a genius too. He was like the head of Bell Laboratories, did a whole bunch of stuff, invented a bunch of stuff, super smart dude. And he was against relativity. He started and his experiment, he says, proved that there was an ether because of like the exact stuff that you were just talking about, Chris. But they swept all that under the rug and co-opted it and say that it's exclusive proof of special relativity, when it's not at all.
Yeah,
it's crazy.
Good stuff, man.
Somehow unsurprising though. Wait, so they lied and then pretended
and they kept lying.
There was proof for there. No way.
No way. Yeah.
So uncharacteristic of them.
Isn't that cool about a flat earth? You find all these things that quote prove the globe, and you investigate. Not only does it not prove the globe, it fails miserably to offer any evidence that actually usually proves flat earth, right?
Yeah, it's
always.
Yeah.
All right. Well,
good shit, man.
Great.
Yeah, man.
Oh, hey, can you link your stream, Shane? Actually, when I adjusted my OBS to show the Ken Wheeler video showing relative motion, I forgot to change the thing back to the presentation. So half of my YouTube presentation is just the Ken Wheeler video covering up the screen. So if you don't mind, can I upload your video to my channel as well?
Yeah, of course. I took all the branding off it. I kind of felt you might screw up. No offense. I got you, man.
Oh, good, dude. You're a saint. You're literally a saint, dude. Saint Shane Pierre? Question mark.
Yep. All it has is like the neon outline, which may be gay, but there's no branding or anything on it. Totally free to upload.
Did you choose gay as derogatory term?
I did choose the neon, so I don't know how I'm using it, to be honest.
You're calling yourself into question?
I like it, so yeah, it is what it is.
Yeah, no, it's dope, dude. Thanks, I appreciate that.